A very good morning to all of you. My name is Ananya Narayan, and I'm Director GW Consulting from Geospatial World, and I'll be your host today for the virtual summit on data-driven connected technologies for quality and productive construction processes in highways and airports in India. This summit is jointly organized by Techknowmics Research and Consultancy, Geospatial World, and technology enabler Trimble. We have 3 hours today and a very diverse and esteemed set of panelists from both public and private sector who shall discuss and deliberate on the need, relevance, and importance of data-driven connected technologies in the Indian transport sector to resolve major project shortcomings such as costs, reworks, project delays, which often arise from disconnected workflows. So without further ado, I'm pleased to invite Lieutenant General Ajay Kumar Chandele, President Geospatial World, to give his welcome address. General Chandele is the former Director General of Electronics and Mechanical Engineers, Indian Army, and is currently associated with many industry and professional associations. Sir, the floor is all yours.
Thank you, Ananya, and good morning, everyone. Well, once again, on behalf of our sponsors, Trimble India, we at Techknowmics and Geospatial World take this opportunity to welcome you to this virtual summit on data-driven connected technologies for quality and productive construction processes in the highways and airports in India. Well, construction technologies generally refer to all the innovative tools, machinery, and the software used for enhancing construction processes and to implement projects in a better manner. In digital parlance, that would mean the hardware, the software, and the skinware, everything which can be used for improving production processes and improving the quality therein. It can be used for small residential projects to very large industrial plants and equipment. These technological enhancements in construction processes have come about as a result of the demand for better productivity and quality. Now, productivity here refers one to speed in the completion of any project, and also in the enhanced utilization and the most economical utilization of available scant resources. As you're aware, that resources are always at a premium, whether they are financial, material, or human. So the most optimal utilization of all these resources is something which we are looking forward with these technological advancements in construction and infrastructure technologies. Now, speed should not be at the cost of quality. Obviously, all the users demand world-class quality of the projects that are being implemented. And they should be uh, projects which are long-lasting and can give better utilization to whoever is asking them to be constructed. Now, also, the speed or the productivity improvement is not at the cost of safety. Safety is of paramount importance, whether it is at the stage of construction of the project. That means that the workers who are involved or part of the project should be protected from all possible hazards that may occur, any mishaps that are going to occur. So all this must be planned and they must be protected against these. Also, the project should not result in degradation of the environment. That safety measures also need to be implemented, whether it is causing pollution or it is resulting in climate change. So all the measures which protect the environment also form part of this safety. Now, as regards quality, the quality should be so good that it should last well, the user would like it to last forever. And also that he should use it optimally, whether it is uh, highways or it is airports, he should be able to utilize it to the maximum capability, to the maximum possible amount of time. Now, construction and infrastructure is one of the largest contributors to the GDP of a country. In our country, too, the investments in construction and infrastructure directly result in improvement of the economy. Statistics which have been released by the Ministry of Statistics and Program Implementation indicate that last year we had a negative growth in the sector to the extent of about 12%. But what was heartening was that in the last quarter, we did see a growth year on year of approximately 6.4%. This was as a result of the massive investments that the government made in the construction and infrastructure sector. You're aware of the large number of projects that are being undertaken in our country, whether it would be dedicated freight corridors, it be new airports being established in tier 2 and tier 3 cities. There is a massive investment which is being pumped into the sector, both by public funds as well as private partnerships. So this is what we hope that in the years ahead, we will see a tremendous growth in the construction and infrastructure sector, and therefore all the more reason for using latest technologies in this field. We have with us this morning an expert panel from this construction and infrastructure sector who will navigate us through the latest technologies which are being implemented in this field. With these few words, I hand you over back to my colleague Ananya to take the discussion forward. Thank you.
Thank you for the welcome note, and also thank you for showcasing the value of technology with respect to speed, utility, quality, and optimal utilization when it comes to material wastage. I think one of the very interesting aspects that you touched was the sustainability aspect, which we often miss out on. So I'm sure we'll discuss more on it throughout the day. Thank you so much, sir. With this, I begin today's virtual summit with a very short presentation on connected construction technologies for nation building. We know that the pandemic has left significant trail of disruptions across the AEC industry all over the world, and of course, so much so in India as well, in its supply chain, in its productivity, and some way or the other, it has kind of motivated and led the AEC stakeholders to realize the need for collaboration, the need for connectedness, and for the need of adopting these construction technology solutions so that the commitment of the government stays strong on building the infrastructure for tomorrow. A brief overview of what the Indian transport sector looks like. And of course, we are going to be focusing more on the highways as well as the airports. So it's a no doubt that Indian transport infrastructure is recognized as the lifeline of the country, and it has been growing at a very high CAGR of 5.9%. And with the National Infrastructure Pipeline, which was recently announced, we have about 103 lakh crores over the next 5 years to the total infrastructure segment. Now, the focus of the government has been very clear. They with the rate of construction at 35 kilometers per hour for highways, and with the Udan scheme in airports, there has been significant budget outlay to both roads and highways as well as to the airport. So we have about 1.70 lakh crores Indian rupees for transport infrastructure to accelerate highway construction. And we have key projects like Bharatmala Pariyojana, which has been going on and which wherein investments have been pouring in. There have been dedicated pipeline projects in the pipeline. For example, we have the economic corridors, we have the strategic highways in making. So the government is very clear what its focus is in the next couple of years when it comes to the highway infrastructure. Similarly, for airports, there are about 3,000 crores has been allocated, of which about 600 crores has been allocated for the revival of 50 plus airports under the UDAN scheme. And the Indian aviation sector aims to be the third largest aviation sector in the country. So in the world, sorry. So the focus of the government is very clear. The government wants to invest in highways as well and airports, and not just in the sectors per se, but in technology implementation as well. So going forward in the next slide, we have a couple of industry challenges that as part of research we have found that there has been 45% of projects today are over budget. So cost is a very major challenge that the Indian stakeholders or project owners face. Then 86% of projects are delayed. And this is something that we keep hearing on and off about, right? So apart from that, most of the construction work, because it's not, because sometimes there are issues in the planning and designing phase. So 30% of construction works today is found to be requiring rework, and that takes a lot of significant time, and that again results in more costs and more delay in delivering the projects. As General Chandele mentioned, that material wastage is one of the core aspects. So we have 25% of materials in the Indian construction sector which is wasted, and all of this together kind of impacts the productivity. So we have seen that 55% of Indian construction job sites are unproductive. What this basically means is quality and productive construction has been a consistent challenge in the construction in Indian highways and airports. So this goes from project conceptualization to the operations and maintenance stage. And despite the prominent stake and despite what it holds for economy and society, the sector's performance lags tremendously behind other industrial sectors like manufacturing or like manufacturing. So, but why does this happen? So this happens because there's a lack of connectedness, there's lack of collaboration, there's lack of interoperability. While technology is one of the core focus areas of the government today, there is still a lack of technology awareness, its value proposition, and of course, there are many other challenges such as skill development, labor challenges, safety challenges. So all in all, today, there is a need for connected construction solutions or data-driven connected solutions. Next slide, please. Just going forward, so what is connected technologies basically? Connected technologies, excuse me, is basically when a data-driven connected technology ecosystem is created, wherein all construction-related information is at one place in real time, available to all stakeholders. So this means that there's a continuous flow of data, which includes geospatial data, BIM data, project and timeline data, machine and equipment data, project delivery data. And all of that, as you can see in the image, comes together in a common data environment, enabling the stakeholders to connect and collaborate on one single platform. That one single platform acts as a whole system in itself, where the whole collaboration takes place, where whole challenges can actually be mitigated. Next slide, please. But what does this mean? So how do the stakeholders come out? We have project owners in a whole workflow of highway and airports or any other construction process for that matter. We have project owners, we have design and engineering firms, we have service contractors, we have industry consortia, we have material suppliers, we have operations and maintenance people, we have prefab and modular construction suppliers. All of these stakeholders need to be connected on that one single platform, on that one common data platform, so that the decision making becomes easy. And with that, there are multiple technologies. For instance, if you see on your right and on your left, there are 3D machine control systems, as well as there are geospatial technologies, there's BIM, there's digital twin, there's site supervision solutions, there's underground mapping solutions. So data from all of this comes together and is kind of synthesized using AI and ML solutions to develop an ultimate digital transformation model for the construction job site. So when all of this comes together, so basically what connected technology is, it is an ecosystem of ecosystems. It's an ecosystem of stakeholders. It's an ecosystem of technology providers, and all of them together come together to make for a collaborative and connected environment. Next slide, please. Now, just quickly getting into what the benefits and ROIs are, I think it's as it's on the slide, it's very clear. We have seamless communication and collaboration. That is what connected technologies ensure. There is a more better and informed decision making, given the fact that everybody is on the same platform. They can interact, they can talk. There is no loss of data, and the decision making becomes simpler. The project delays are less, the costs are less, the reworks are less. Sustainability becomes a very important component, and there is real-time data sharing, and there is minimization of risk. Following that, next, we have about 12% of time savings on using connected construction technologies, about 20% of cost savings, and at least 78% increase in accuracy. So these are a couple of benefits and ROIs which are critical, which is something that a stakeholder will derive if they use connected construction technologies. Next, please. Just quickly getting into India's maturity. So the lighter blue dot is where India currently stands. There is a level of awareness about what connected technologies is, what data-driven technologies is, but somewhere down the line, the adoption and implementation of it is minimal. And the reason for that could be skill development. The reason of that could be a lack of understanding of the actual value proposition that these technologies bring in, and maybe because of policy mandates or quality standards that have been established. So for India to reach that level, wherein the connected level, wherein we have GNS is enabled 3D machine control systems, we have additive construction, we have digital twin, wherein we have AI, BIM, all those solutions, it requires specific focus for India to move from level A to level B. And this could be done through a couple of steps. Next slide, please. So there are four ways in which this can be taken forward. One is to create awareness about the value proposition of connected technologies. There is a need to undertake initiatives and activities of making sure that stakeholders are aware of the value proposition of connected technologies in both Indian highway and airport projects. There needs to be a significant value-based documents need to be available on the return on investments that can be generated. Apart from that, technology policy mandates and quality standard specification. There's a need to develop comprehensive policies and guidelines and mandates for the increased adoption of these solutions. And government and user stakeholders, that is public, private stakeholders, and even academia in some cases, need to work together and mandate these technology benchmarks for the whole life cycle of built assets. Thirdly, there's a need to embed connected technologies as part of procurement processes. So develop a definitive and standard procurement mechanisms, amplify and simplify the approval process of technology procurement by project owners or by construction stakeholders, support improved relationships across clients and supply chain. And lastly, research and development, community and engagement. There is a need to fund research and development projects, provide professional training modules in connected technologies, and establish center of excellences for developing more connected technology solutions. So going forward, keeping in mind the need for data-driven connected technologies which encompass a dynamic connected environment of construction softwares, 3D machine control systems, and field solutions. It is important to use connected technologies to fast track the design to execution tasks in highway and airport projects. And with this, we begin the day. Before I invite my next esteemed speaker, I would just like to lay down a few housekeeping notes for the day. I request all attendees to please send in your questions in the chat box on your right. In the sessions particularly, we will have a dedicated Q&A session after all presentations. We will also be running a few polls, and you will see a brief ticker when the polls are live, and we request you all to participate actively in the same. To the speakers and sessions, request to please keep your presentations for 10 minutes and not more than that. We would really like to make the sessions today as interactive as possible so that we can address as many challenges, as many topics that are at hand and that can drive the adoption of this technology. So for the inaugural address, I'm very pleased to invite Mr. R.K. Pandey, Member Projects, National Highways Authority of India, to give his talk on adoption of digital technologies in highway construction in India. Over the years, Mr. Pandey has played a pivotal role in emphasizing the role of digital technologies in the transport infrastructure sector, particularly highways. This is a subject which interests all of us, as NHAI is one of the premier institutions today to commit and adopt technology to enhance transparency and accountability and for smooth, quality and productive construction processes. And of course, who can forget to achieve a record rate of construction of 34 kilometers per day? Mr. Pandey,
sure.
Request you to please take the stage. Thank you, sir.
Good morning, everyone. I hope you can hear me clearly.
Yes.
Friends, before I begin, I would like to congratulate the organizers. Today, we are passing through a time when we are looking for elimination of the human element and keep it to the minimum possible. As many of you might be knowing that in highway construction, we have created 3 world records. Number 1 is highest in kind of construction, 37 kilometers a day. When I'm saying 37 kilometers a day, it means it is not lane kilometer, it is kilometer. It could be 2-lane, it could be even 8-lane expressway. Number 2, we have laid maximum quantity of concrete pavement in a single day. Similarly, on the bituminous side, we have laid maximum length in a single day. It was around 25 point some single lane kilometer. So having this kind of record, what is needed? You'll have to have some kind of program for it. And for highways, we have a very ambitious program. That program is called Bharatmala, and basically it aims at providing direct connectivity between 2 points. And today, our whole emphasis has been changed from widening our capacity augmentation of the existing road to providing greenfield corridor. This has been possible because of a very simple reason, because we utilized technology at the time of planning. When we launched our earlier program, which was National Highway Development Projects, we have only traffic on a cross-section point. Means I know at this particular point what is the traffic. If traffic is exceeding the capacity, I'll have to go for the capacity augmentation. When we launched Bharatmala, we had the origin and destination survey. We have full data about the freight movement amongst the 600 districts in the country. So I know that which point is to be connected by which point. Because of this facility, because of this technology and data analytics facility, we identified straight greenfield corridors. We are not following the existing alignments. So, when we talk about highway sector, basically the whole project life cycle can be broadly divided into three stages. Number 1 is the project preparation, number 2 is the construction, and number 3 is the operation. As far as project preparation is concerned, we have adopted technology to great extent. Because when we'll have to construct 37 kilometers a day, I'll have to have self projects ready with us because it itself takes time. We have moved from manual way of conventional way of doing surveying or project preparation and utilizing technology to the maximum extent. And today, all our projects are being prepared utilizing the technology. But when it comes for the construction, there we are certainly lagging. We are lagging. There could be two reasons for that. Basically, when a technology is introduced, there are two ways by which it can be introduced. Number one, leave it to the technology provider to convince the vendors that by adopting their technology, they are going to do faster, or means they are going to do in an economical manner. Number two, governments pitch in and government formulates certain kind of policies which make it mandatory to utilize those kind of technology, and it is mandatory. Someone who has that technology can only enter into the arena or can participate in the bid. As far as technology is concerned, yes, of course, there has been both two-pronged strategies have been adopted. In fact, I'll say when we talk about technology in construction, we have taken first step. When I'll say taken first step, we have not gone digital, yes, but we have moved from manual way of construction to equipment-based construction. But yes, digital, we are lacking. For going for digital, yes, that is the need of the hour. As far as NHAI is concerned, we are fully convinced that it is going to be a kind of productive implementation. It is going to help me in achieving my objectives. As President in the opening remarks said, today what we are looking for. I am looking for very fast construction, which is very accurate, with quality construction, safe and sustainable. Any technology which helps me in achieving one of the objective is a welcome start. Today, fortunately, we have number of mathematical modeling available with us, which help us to carry out the whole life cycle cost analysis. It means we are taking into account all kind of costing in our decision making before we arrive on a particular kind of decision. Coming to the propagating use of technology in construction, yes, as I said in the beginning, we are convinced and we would like to introduce in a big way. The challenge before the authority is, it is not the authority alone. As I said in the beginning, we are constructing 37 kilometers a day. It means if I make any technology mandatory, all the vendors, when I say all the vendors means 200 plus contractor should have, they should have easily available that kind of technology. Number two, technology at what cost? Number three, even if they have technology, whether the technology provider has the capability or the capacity to give them the full skilled people who can make sure that whatever he has opted for, he is in a position to utilize it to the full extent. Today, of course, we have not mandated use of digital technology in construction for these reasons. But of course, let me tell you, we are working on a procurement where we would like to construct an expressway, where we would like to mandate it to all the vendors to have technology available with them. For mandating or making it compulsory in our tender document, I'm looking for a number of issues. I'm sure during this your summit, you would like to deliberate upon all these aspects and what is the requirement which I'm looking for. I'm looking for something which can give me, say for example, as a highway construction agency, what I am doing. My project preparation is fully digital. Data can be transferred from consultant to the contractor. That is not at all an issue. Only I'll have to have an approach where the contractor can talk to consultant and consultant talk to the contractor. Then contractor can talk to the authority. We have taken another step. In your presentation, you talked about delays. Today, we are not depending upon letter writing. Our entire correspondence is through a portal we have developed that is called data lake. Means every communication is through the data lake. What is happening every day is fed into the data lake. But it has created a problem for me in the sense my field units are flooded and they are loaded with putting data in the data lake. What they did the whole day, what kind of material arrived, what kind of earthwork they did, what kind of bituminous work they did, what kind of aggregate they crushed, what kind of PQC they laid. So what I'm looking for something where machine can directly communicate that, yes, we have done this much. My human element is totally eliminated from this whole process. It will make my process very transparent, open, and we will be confident. But what I'm looking from the technological provider, that they should give me a kind of confidence that the information which will be provided to you is reliable. When I'm saying reliable, it's in two aspects. One is in terms of the quantum of information which is supplied. Number two, in terms of the accuracy. Say, for example, I'm laying a earthwork where I can tolerate a accuracy of 10 mm, but when I'm laying a structural concrete, my requirement may reduce to 2 mm. So up to what point the service provider can give me a kind of confidence that, okay, you can rely with 100% reliability that, yes, the information coming is accurate, 100% correct, and it can be interpreted in terms of the content, which is a legal document. So I'm expecting from the industry that you give me the specification for all these, which I can implement. Number two, where we find it difficult to implement the technology is whenever we talk to our vendors. The things which they, express their apprehension is about the cost of the technology. I'm sure when we go for such a large scale kind of adoption of technology, the cost should reduce. The technology provider should support us and give the most optimal cost. We are willing to implement it. As I said, we are in a process of framing a contract document for an expressway, where I certainly would like to have feedback from the industry that the kind of work required is earthwork, bituminous construction, and concrete construction. What I'm looking for, daily progress. What I'm looking for, the thickness of the different layers laid at site. If you can give me density, perfectly okay. If you can even go further down and give me the bitumen content or cement content, it will, it will solve most of the problem. So this is what is my requirement. We are already working on it. I certainly would like to be benefited from this conference, and if I get some feedback, it will help me to a great extent. Coming back to the operation side of it, yes, of course, we are in an era where we are building the highways. But that day is not far when it will be treated as a service organization. Of course, even in operation, we have moved and started utilizing FASTag to the great extent. And today, our toll collection is through FASTag. But FASTag is not the only one option. Ultimately, we'll have to go for the intelligent transport system, which will encompasses everything, because when people are paying, they are expecting that I'll provide them not only a good road, a road of a quality which is promised to them, but also different type of facilities. When I say facilities, it includes even the kind of wayside facility or the all kind of facility which I am going to provide to a user. In fact, when I see people may not be looking for the milestone that Jaipur or the Delhi is 200 kilometers away from this place, but they might be looking for time required for traveling from this point to that point, because that time will vary depending upon the weather, depending upon the traffic, and it will vary every now and then and change with the passage of time. So people may be looking for that kind of facility on the highway, and we are planning. In fact, we are working in this direction as well. But our first priority is to introduce technology construction. Then we'll certainly move towards the operation point of it. I'm sure you will debate on it and give me some feedback. I wish a grand success for this summit. Thank you very much.
Thank you, Mr. Pandey. That was certainly very insightful. Thank you for highlighting all the achievements of the highway sector and throwing light on the ambitious plan of Bharatmala Pariyojana program. We have been studying the program for the longest time, and it is one of the most well-regarded program in the highway segment. Also, the move from the manual, conventional way of construction to the technology way in project preparation in these highway projects and its life cycle was very well established by you. It was also good to hear about the need for government mandates and policies in the construction process, particularly with respect to ensuring productive implementation of technology for accuracy, quality, and safe construction. So I think one of the key things that you brought out in your discussion was about the changing procurement processes that you plan to bring about in one of the high expressway projects via tender documents. And I think the message to the industry is very clear on what is the requirement from them with regards to technology specifications, how can they work alongside the costs and other details. I'm sure we'll discuss more about it during the day, and we will have some sort of benchmarks that we can establish via discussions here today. So thank you. It was good to have you here and listen to you personally. So going forward, in this ecosystem of data-driven connected technologies, I think it's but very clear that the role of a technology enabler is very powerful. And Trimble is one such technology company. Today we have Mr. Rajan Iyer, Managing Director, Trimble India with us, who is going to showcase the technology industry perspective on connected technologies for construction in India, focusing particularly on the value proposition, on the questions raised by Mr. Pandey, as well as what needs to be done next. So, Rajan, the floor is with you.
Yeah, thank you. Thank you, Ananya, and pleasure to be here, and very excited to hear Mr. Pandey talk about the sea change that's happening in NHAI from a lot of paper and a lot of files to going digital, and some of the fantastic records such as the kilometers per day. I think these are all great steps in the right direction, and these are exciting times for Indian infrastructure because there is a commitment on part of the government, the bureaucrats, and the entire ecosystem to build world-class infrastructure at a very fast pace at optimal cost. And also people, as Mr. Pandey said, people are expecting higher and higher, in terms of their expectations, reduced time, smooth roads, no tire bursts, no, waterlogging, all-weather roads, etc., etc. So I think the expectations are rising, and technology is the only panacea to achieve all this and satisfy all the stakeholders, from the owners to the contractors to the the subcontractors to the tradespeople, etc. So I think Trimble is a leader in creating this ecosystem in such a way that people talk about digital. We talk about digital data, digital information, and then digital knowledge and intelligence. So we are progressing from data. Data is great. We need to convert that into information, use that information to get knowledge, gain knowledge, and then use that intelligently the next time around so we can continue to improve. And the digital technology allows us to measure. See, there is a very basic paradigm that if you can't improve what you can't measure. So always we have to measure ourselves against what we are doing now versus where we should be. For example, we started at 12 kilometers per day, and now we are at 37. Now, if nobody knew that we were doing 12 kilometers per day and everybody said, oh, this is great, we wouldn't have achieved 37. And I'm sure the minister, Honorable Minister, Mr. Gadkari is not happy with 37. He wants to go to 50. So the way things are happening is time is getting compressed, quality is enhanced, cost is reduced, and the volume of traffic increases exponentially. India is supposed to be one of the third largest economies in the world very soon, in the next couple of decades. We need to have, with the kind of programs that we have, we need to have a world-class infrastructure that everybody can appreciate, whether it is airports, highways, rail, high-speed rail, ports, waterways, and so on and so forth. So I think digital construction is very, very key. Now, Ananya and Mr. Pandey talked about all the pluses. I'm here to highlight what are the challenges in adopting this technology and try to answer some of Mr. Pandey's questions. I think one of the challenges is that we have various stakeholders in a construction process. We have the owners, we have the consultants, we have the contractors, we have the subcontractors, and so on. And if I have to be very blunt about it, the objectives of all these stakeholders do not always match. For example, if I have to create a linear alignment, the owner will always want an alignment which reduces the cost. But it could be that the contractor wants to add bridges and cul-de-sacs and culverts and so on, because that's where they can make more margins. Because contractor is operating on very thin margins, so they would like to have something where they can enhance margins. So and similarly the quality, right? Obviously the owner wants the best quality at the lowest cost, whereas without the use of technology, how do you measure that? So there are some conflicting, I would say, objectives that can be overcome by having transparency using digital technology, because we measure everything. If a compactor has to compact a runway or a road, we know exactly how many passes were made, what is the compaction value that was created. Now, that actually helps the quality of the road, but it obviously, if a contractor doesn't want to create that value and also showcase that value and then show it transparently to the owner, then he may not want to use the technology. So the first thing is things have to be started with the owner. The owner has to mandate, or at least say the contractor will be given additional points if he uses these technologies, because it helps the owner measure the project. It starts with the owner because that is the root of the entire project, right? Similarly, the project management consultants have to understand the use of these technologies, and which makes it easier for them to deliver the project to the owner with the highest quality and lowest cost. The owner should also encourage the contractor to finish the project early and have some kind of early finish incentives through the use of technology. The technology providers, and I can tell you that Trimble is definitely very flexible in its approach. We have to have the appropriate cost. Obviously, if the machine is costing 1 crore, I cannot have my technology cost another crore. But for that to happen, it's a chicken and egg problem, because for that cost reduction to happen, I need we in Trimble are very innovative. We are talking to the contractors and saying, okay, we'll put it on the machine. You rent it for some time. Once you like it, because we are so confident that we will reduce the cost of operations, cost of construction to the contractor in such a way that is single-digit margins could go into double digits. If the margin increases by 1%, 1.5% in the project for them, they will more than adequately pay. But they are so used to their way of doing it, and in some cases, I mentioned about transparency, right? They say, "Oh, main aise kar raha hu itne saal, what should I change?" But the point is, we have time and again showed them that their cost of construction goes down. That's the first point. The second point is, in future projects, they'll be able to bid very intelligently, because they will have so much data from this project. They can use that data to bid intelligently in the next project and increase their margin. So it is not a step function where they see a fantastic improvement, but if they use the technology over a period of time, they are going in the right direction and going up and up and up. There is only one way they are going up and up and up. And if they are able to finish it with highest quality, I think one of the great things that is happening in India is the contractor is also supposed to manage the road. That means he's not only just paving and paving the road and running away. He has to maintain the road, and he gets some money out of the maintenance. So the lower the cost of his maintenance, the better off he is in terms of the total cost of project construction and operation. So the contractor has to look at it from a project life cycle, a road life cycle point of view, not just construction. So if I add up all that, so higher quality, early completion incentive, lower cost of maintenance, and higher profitability, if I add up all that, I think they will come out much ahead than where they are now. And they can bid on more projects with less people, less machines. So everything continues to add up. And as vendors, we are always trying to talk about this value proposition, but where we get hit is at the procurement level, where they say, kitna deta hai, how much can you reduce and so on. And then, as I said, we have interesting business models, but unless something is mandated saying, if you use this technology, you will get a bonus point. For example, we had a recent tender in which the owner had a QCBC, which is quality and cost-based approach. So they didn't just go for L1, but they looked at the technology, the quality of the technology, usefulness of the technology, and gave higher marks to us. And even though we were slightly higher, obviously not very high, but slightly higher, we won the deal because at the end of the day, the QCBS gave us higher points. Something like that has to be done, because if you're pure L1, everybody's going to try and cut corners. And believe me, at the end of the day, who suffers? The taxpayer, the public, the owner, and the contractor, because they have to keep repaving the road. So I think that this ecosystem, everybody has to come together, sit at the table, have an honest discussion. We are willing to work with NHAI and the top 200 contractors. We are going to guarantee that no contractor, when he puts our technology on their machines, is going to come to me and say, take out that. Everybody is going to say, leave it. And believe me, what else he's going to say? Don't tell my competition that I have this technology. So I am so confident, I can guarantee you today that that will happen. But we need to work on it together. So I am posing a challenge to everyone, saying that Trimble is willing to come to the table with NHAI, with Ministry of Roads and the contractors, have a technology seminar and show them. And we will take them to already using contractors who are already using the machines, and we'll tell them, can we remove this? And the answer will be, no, you can't, because we have so much productivity improvement, we have so much quality improvement. So with that, poser, I would like to stop here.
Thank you so much, Rajan. As you rightly mentioned, it is indeed an exciting time for the Indian construction industry. We are on our way to build world-class infrastructure at a fast pace, at an efficient cost. Very rightly said that technology is the only panacea which brings together all stakeholders for enhanced collaboration. And we look forward to taking this discussion forward to achieving the rate of construction for 50 km per hour, which is definitely a dream. Also, thank you for highlighting the challenges. It is true, till we don't understand these challenges, we cannot solve the issue. And understanding that all the objectives of all the stakeholders is definitely different. And that is, I guess, what makes them work in silos. And this is where connected technologies and connected construction solutions, data-driven, comes into play. So thank you, Rajan. Look forward to a more detailed discussion in the last session today. With this, we come to a close to the inaugural session, and the next session will be moderated by my very able colleague, Kasi Rajan Mahalingam, Industry Manager, AC and Digital Cities, Geospatial World. Kasi, before I hand over to you, we have a short video for our audience. Thank you.
We live in an amazing place, in an amazing time.
Someone should make a highway that floats in the sky.
There's never been a more opportune moment to plan bigger and accomplish more than ever before.
I think we should live in buildings that change every season.
Doing more is the opportunity that the teams at Trimble focus on every day, and occasionally all night. Delivering an ecosystem of construction-ready solutions and services that align all efforts, expertise, and resources available, from survey to design and construction through operation, with continuous optimization. So you can document the unknown, foresee the unpredictable, and assure the best outcomes possible. Because when you have the tools to capture context and share data, you can move the machines. You can remove all the obstacles. You can craft a confident path forward to carry the next plan forward.
Someone should invent a way to see the whole world in just one day.
In our field, there's only one better feeling than to see a brilliant plan become the next modern marvel. And that's the opportunity to say yes. Yes, I did that.
Hi, a very good morning to everyone. Thank you, Ananya, and the panelists so far for setting a great start for the day with crucial insights into the state of construction and infrastructure development related to highways and airports. We're about to begin this session on technology breakthroughs for efficient and accurate architecture and engineering design. I'm Kashi Rajan, Industry Manager for AEC and Digital Cities of Geospatial World. As emphasized by our renowned panel members in the introductory session, the need of the hour is focused towards precise engineering techniques followed by sustainable solutions, resulting in asset longevity and performance assessment. Needless to say that the adoption of technologies in this regard come with its own sets of challenges, from digital transformation strategies to human resources acquired to interweave these technological solutions into the present project workflows. Recent studies indicate that 66% of the construction companies in India suggest that digital transformation and data-driven solutions need to be prioritized. This has been echoed by stakeholders across the value chain, which includes your owners, contractors, and engineers alike. Although majority of construction companies in India are still in the early stage of this digital transformation process, the benefits of this transformation are acknowledged by the industry nonetheless. Construction companies can ensure operational excellence and improve customer engagement by effectively managing risk, completing projects on time and on budget, improving workforce safety, and overall support the infrastructure growth altogether. Without further ado, I hereby introduce the esteemed panel members for this session to discuss the technological breakthrough for efficient and accurate design and engineering techniques in highway. We have in our behest Mr. Amrendra Kumar, CGM, Tech, National Highways Authority of India, Mr. Manoj Kumar Gupta, Chief Engineer, Uttar Pradesh Expressways Industrial Development Authority, as well as Mr. Harsh Parikh, the Regional Sales Director for Trimble. I hereby request Mr. Amrendra Kumar to begin his presentation, his narrative towards this session. Sir, please.
Thank you, Kashi Ranjan. First, going forward from the inaugural session and the note set by Shri R.K. Pandey Sahab, member NHAI, the authority perspective is to encourage this digitalization and connected technology, and to give a thought in fast-changing world. We have, in last 2 years, we have implemented the 100% FASTag. Another related data is all vehicle data is integrated in an app called Vahan, and we have immense use of mobile GPS-based mobile. All these three data combined can provide such a large and valuable data mine for highway planning at micro level as well as macro level, as members has hinted earlier. In Bharatmala network planning, that freight corridor data that was available at that time has been used and efficient network has been planned. Just now think of we have almost 800 toll plaza and all vehicles are equipped with FASTag. The all vehicles data is available in a Vahan, a software of the Ministry of Road Transport, and there is so much use of mobile-based GPS. All this data is so valuable for highway professionals. It for planning the macro network of national highway and other road network, and at micro level also, where we have to plan a junction. What is the data available? Earlier, we have to rely basically on the OD survey that is generally done for 3-4 days or at most 7 days, and that is based on some queries. And now we have actual real-time data of these FASTag-based data, GPS-based data, and all toll plaza is linked with camera also. These are very valuable data that is need to be analyzed in a efficient manner using probably AI also, and our one aspect of highway planning can be very adequately taken care by this data. To start with, just I have given you this data to open up the mind that this world is changing so fast and our implementation is also being fast. So we have to adopt new technology. Still we are stuck with OD service, but not using this heavy data of FASTag, Vahan, GPS-based mobile in our surveying work. It needs to be done in a very large scale. It is being during the toll 100% FASTag implementation. Toll congestion was one issue. So we have used this mobile GPS-based congestion. We were analyzing the congestion at any toll plaza. If it is more, then we were giving some intervention. So authorities also using this innovative technology in partly manner, but it needs a large scale implementation. The different stages of highway planning is all know. First, start with planning of a network that I have given hinted with large FASTag data and other data. We can plan in a more efficient manner. In a specific highway alignment, when we plan it, then also these data can be of much, can add value to them. Axle data load is also one parameter, and capacity augmentation when highway is required for capacity augmentation. That estimation is also not done presently very efficiently, but using this data of FASTag and other things, we can estimate our traffic growth, etc., in a very efficient manner. This is food for thought for our all stakeholders, and it needs implementation. Survey, another aspect, generally we allow consultant to use this modern technology. NSV data has been used and meant compulsory for all survey work for any national highway work. And the problem area that I feel is for highway and mountainous region is, apart from this survey, we have slope stabilization work requirement of tunnel works, where a tunnel is to be done or not, is also to be explored. That is by only this physical survey, that is not possible. Even with geotechnical boreholes, etc., that is not sufficient. The remote survey is also required. That many data are another area that I want to put forward here is, in a particular area we are planning a national highway or so. In that area, some other agencies also working for, say, tunnel works or any other work, or say railway is working. So these all data are kept in a different silos with different agencies. We have to evolve a mechanism. All data, related data, that is held by different agencies for a particular area or across the area also in a different geographical manner, that should be kept in such a manner it can be used or retrieved by other agency also. This has been planned in a there is a one group made under the Ministry of Road Transport and Highway for hill and tunnel work. This is the one agenda for them also. There are so valuable data held by different agencies that is not presently not being used by other agencies. This should be kept in such a fashion that it is readily used for other agencies in a easily retrievable manner. As far as project implementation part is concerned, the NHAI evolved a contract document in which either it is a EPC based document or BOT toll or presently being done on HAM project. It is a long-term contract where the design responsibility is given to contractor. When the contractor is given design responsibility with the idea that contractor will evolve these best technology available, and they will minimize the cost, life cycle cost. They will manage things in an efficient manner, and they will arrive at a minimum life cycle cost to bring efficiency in the system. So from here, this contractor has to adopt better technology, whatever is available in market. And another area that is the responsibility of owner or authority is during the operation and maintenance. During the operation and maintenance, the present data availability, like GPS-based mobile technology, that incident management has become very recently. There is need for improvement in this respect, but presently it is being adopted. The ambulances are fitted with GPS equipment, and our control system, whenever a person calls a phone, its location is noted, and that incident management can be provided in a very efficient manner. As far as the authority is concerned, the contract administration has been largely digitized. There is need for improvement also, but in this pandemic time also, our working is totally e-office based. Or pan-India working is, all government offices are working on e-offices. That is very efficient. There is no requirement of any physical file, but e-office in a digital form, it can move from one official to another officials, and all whatever working has been done in a physical manner, that is done in e-office in a very efficient manner. It is during this pandemic time also, when NHAI has achieved the highest construction, then it is partly is the reason that the work has been shifted largely to the e-office now. There is a need of improvement. This flow from local offices also, or from contractor correspondence, should also be linked with that. That improvement is done. Another innovation by NHAI has been done in contract management is based on data lake. It is partly this improvement in contract management and timely action to be taken in the key factor that is in a key contract management is required. Data lake presently it's working properly, but all correspondence with either with contractor or consultant has to be done in a digital manner only, and it is recorded in data lake. And if the key parameters is monitored automatically by data lakes, and it provides trigger to the concerned official, it is this action is pending at this level, and this give a trigger to the higher officials also. This has to be implemented in this time-bound manner, and it is not done in a time-bound manner, so it's provided trigger. This in the entire ecosystem of highway management, this is from owner side, the innovation has been done. There is much larger improvement is to be done. And I hope that since the time limit is provided of 10 minutes only, so I want to highlight these things, and further improvement is certainly required in all aspects of working. The ideal situation will be for that the digital data collected by a consultant is efficiently, seamlessly flows to the authority in a bid format, and a bid format that is after the successful bidding to whoever is successful bidder, that the entire data seamlessly transferred to the contractor, and contractor while implementation this digital data that has been provided during contract, that becomes part of the software of PMIS software, and the all key parameters, whether this technical detailing of alignment, breezes, tunnels, etc., that and its timeline implementation, its quality of implementation, its specification for implementation, that is already embedded in PMIS, and the actual work done by contractor at site, that is also is key into this PMIS in a physical manner or in a digital manner through photographs also by different surveys and tests, etc. That is also feeded. That is the ideal solution. We have the digital data gathered at the time of survey that has been transferred subsequent to the successful bidder. That becomes a part of PMIS, and that's actual implementation and its states and desired specification and actual specification is also matched, and wherever deficiency is there, that is being figured, and successful completion, it's become a part of the as-built drawing, etc., and subsequent during monitoring, it's become in a continuous process. This is the ideal solution in my view. Presently, we are doing in a parts, it needs assembly of entire process, and that is challenge for all stakeholders of highway construction. It should be done such that it's user friendly, and it's larger, the objective of this larger, our fraternity of all stakeholders to build a highway in a least cost. Quality of highway is also very high. It is done in a time-bound manner, and it is provide the requisite convenience to stakeholders. With this, I end my lecture. Thank you.
Thank you, Mr. Amarendra. Thank you so much for acknowledging our request, firstly, and giving your narrative, including the challenges and the type of solutions that is required at the earliest for the industry to function and improve its quality as well as accuracy when it comes to data management and data sharing amongst different stakeholders. With this, thanks to you for setting the platform, I request Harsh Parikh from Trimble to take up the stage and try and help us navigate these challenges that Mr. Amarendra has nicely put up. Harsh, over to you.
Thank you, Kasirajan. I hope I'm audible. Good enough.
Yeah.
Thank you. So today's topic where the discussion is going around is all about data-driven connected construction. Mr. Pandey spoke later on. Rajan also emphasized, and we just heard that how digital construction is going to be the key for our future construction methodologies, and it is inevitable. Why do we need the data-driven connected construction? That's the first thing. The way I put it, if we want to deliver our project with confidence, that's the ultimate requirement. That how do we bring the transparency? How do we bring the visibility amongst key stakeholders? And how this digital information can be fed into the last milestone during the construction, and later on can be utilized for operation and maintenance perspective. So the whole essence of this data-driven construction is primarily to deliver our project with confidence that there is no error, no delays, no time and cost overruns. To avoid those challenges, we need to have this data-driven connected construction. I'm going to articulate a bit more about this data-driven connected processes. What essentially it talks about. The connected processes allows different stakeholders for a project. I think typical three key stakeholders. We talk about owners, we talk about contractors, and we talk about the design consultants. these are the three primary stakeholders where the information, they have their own set of information, and then they need to share why do we need that. So everybody is making a good amount of transparency in terms to keep project budgets or project schedule, ensure the scope of the project is delivered as per defined, to finally maintain the quality and safety. Quality and safety is the most important. In the recent past itself, we have seen some calamities, some unfortunate events in the highways. I think if we cannot avoid, we can certainly minimize certain instances if we are able to create the entire digital data before the execution. So we basically come out of those challenges. So what is this connected construction? I give you, you can see in the centerpiece of it, there is a building, and this is nothing other than the digital prototype of any construction project, be it a building, be it a road, be it a bridge, or anything which is going to be on site, on ground. If we can prepare a digital prototype before it really goes for construction, can provide us a greater amount of information to execute a project with absolute transparency. And it allows us to give it allows us to be more informed about our decisions and execution steps we are taking. It is at Trimble, why do we call this as core? It is having a foundation pillar on three major elements. The first and foremost is constructible. Constructible is nothing other than as built. What is going to be on site, it needs to be as built. The second thing, to make it as built digital model, the content is very important. So content enabled, that how do we reinforce this digital prototype and digital model with the data? So the content needs to be fed into it. And I'll show you a couple of examples around that what do we mean by it. So that is the second most important thing. Last but not the least, in the present context where everybody wants to be connected, not connected only in terms of passing on our emails or probably talking, the collaboration between during this engineering, design and construction phase, how the engineering information gets flown from one phase to another phase, from one stakeholder to another stakeholder, and how do we keep all the stakeholders connected is very, very important. So these are the three core elements of the data-driven connected construction, where the information which needs to be prepared before the execution happens has to be constructible, content-enabled, and connected. So these are the three elements. I'm just going to share some examples that what constructible means. So you talk about constructible, and let us see a digital prototype of this bridge deck on top, and this is a composite structure which has a lot of steel component, which has a lot of concrete component, and what goes inside it. Like recently I've seen like some of the advertisement comes in like what goes inside nobody sees, but actually it matters a lot. So when we say constructible as built means it is not just about having a 3D model, it is about what goes inside the 3D model, and that is what basically ensure the quality and safety of our projects. So this is one example, and what basically it allows us to do all the safety measures, cost measures, and good planning around the execution that and generate the documentation which are required for proper construction execution. And that is why we call this as the constructible BIM. I think BIM is a very generic term nowadays everybody uses, but the right way of putting the data across in a construction form is what I call as constructible BIM. And here, the documentation where 80% of the time is being spent today is a byproduct of your constructible BIM model. So you can see that this is a digital model, and this is a small portion I've taken, but it has all the information required for spend time on. And that's the reason we call and we give this terminology as constructible BIM. BIM alone is being termed as just a 3D model, but the information which are required from the execution purposes has to be built inside. We can't just leave them. So that's constructible. When you talk about content enabled, so there are, look at in every project we have utilities like heat, ventilation, air conditioning, ducting. You have a lot of structural elements. There are couplers there are different type of reinforcing bars, there are studs. In bridge construction, there are a lot of element comes in. So even the smallest level of information, if that can be given inside this digital model, that is going to make its constructible. So you can see there are multiple, and Trimble is committed to provide the content across any of the project, be it building construction or be it a bridge construction or be it a road construction, anything we talk about. You can see these are the different resource centers, and nowadays everybody talks about cloud hosted solutions, and these are nothing other than the cloud hosted libraries, which consist of more than 31 million catalogs presently, which can be simply downloaded from more than 5,000 building product manufacturers. More than 90,000 engineers and contractors basically nowadays downloads and uses that. And every item which is needed to construct that virtual data model will be possible by using this content-enabled data. I'll give you one small example. Look at this. This is nothing other than some mechanical items. If I just click on this, it takes me to a website on Trimble, and where you can see that these data are available here. It basically talks about data from which country origin. Here, if you see here, it talks about which country origin this data. So I think every country origin data is available, of what category. So whether it's a building or electrical or mechanical or sprinkler, ventilation item, from which manufacturers. So you can see number of manufacturers. I think every single manufacturers from any category can be available, and then these data are available to download here. You can just go and download. This is a small example. I thought it is good to share. So that's how basically we provide the rich content. And what do we mean by connected? The connected means how this information is available. So the three pictures gives a self-explanatory thing, that whether it is a desktop, whether it is a tablet, or it's a simple mobile phone today, the information which are being created at any stage of the project by any of the stakeholders, the connection is there. It can be accessed in any of the mediums available at any point of the time. So we call it like access anywhere by anyone. And nowadays, the new technology which talks about this connected information, nowadays we talk about AR and VR, like augmented reality, mixed reality, virtual reality, where this virtual data you can actually take on site and you can superimpose this digital information on site. So you can actually see that when the construction happens, how the things are gonna be. So this is very, very important. That connected does not mean that we are just exchanging our data or emails, but it is exchanging information on any platform for the construction and quality purposes. So this is what we call in-field. So it is not only about creating the digital model, but capturing the information, doing a complete field visualization, and then sending this information, like transposing that information on the field with these digital devices. So Trimble is unique in its nature, which provides the combination of hardware and software and services to ensure that once the projects are conceptualized in this manner, they delivered on time, and there's no time and cost overrun. And finally, how do you track this information? This is what we call connected lifecycle workflows and reporting, where every information which is being created and what is getting basically executed on site can be maintained in online cloud-hosted application, where you can do the complete drawing and document management. You can manage your submittals. You can maintain your minutes of meeting across the project lifecycle between different stakeholders. RFI management, different file repositories, workflows and emails. That's of course part and parcel of this, which I think many times is being talked about. Variety of reports, that what is happening on site every day, what kind of reports are getting generated to track the status of the project and maintain a complete dashboard. This is not about one project. In fact, the multiple projects can be maintained in this fashion, that if there are 30 corridors are being planned or in execution, then how each of these corridors, this brings a lot of transparency. This brings like a clarity in terms of our execution and how basically things needs to be properly managed. So that's what we talk about connected construction, right from concept design to an operation and maintenance perspective. I want to, there are multiple solutions, but in interest of time, I want to just highlight a couple of solutions today, how basically it helps in this connected life cycle. And I'm just gonna focus on the preparatory phase of the information. I think in the following sessions, we'll see the machine-based control systems, how this data gets used on site. So first and foremost is about the feasibility study and concept. In a linear project, how the feasibility study today gets done, it takes maybe easily more than like 4 to 5, 6 months to just come up. Mr. Pandey spoke about preparing a greenfield corridors today. We are talking about Bharatmala. On the railway side, we are seeing the new freight corridors are coming, new high-speed rail corridors are coming. And these are kind of a greenfield stuff. So how do we prepare this feasibility study? There are 4 components and needs to be like put together. There's a solution called Quantum from our technology team, which has come up, and what basically does, you want to go from point A to point B, and there are 4 sets of information we want to combine. Engineering aspect, environmental aspects, demographic aspects, and topographic aspects. If these 4 different elements, these are the 4 basic ones which I'm saying, but the information today is available in different mediums and ways. We can leverage this information, and this is cloud hosted system. You want to go from point A to point B, just feed those information, and within hours, I'm not saying days, within hours, you can come up with more than 100 such alternatives from going from point A to point B. It not only gives us the most cost effective, but it gives us the most safe alternative. And it is up to us what to choose. So in present situation, because we are still in the early phases of digital adoption at this stage, a lot of data is manually getting created by using some softwares. However, how do you improve your decision making? These are the cloud-enabled solutions which leverages the different informations and gives you a variety of alternatives to reach on a scientific approach based on scientific approach, that what is the most optimal route in terms of safety and cost. That's one. The second thing I'm talking about, TLOS. This is another unique solution for construction schedule and project management.
Hi, Harsh, I'm so sorry, but we are running out of time, so please.
Last 2 minutes.
All right.
So that's here. And this basically brings a three-dimensional picture of your project planning. Most of the softwares plans only time and activity, but here we are talking about time and activity with respect to a location. So this is how, if there is some activity being planned in between at a particular chainage, if we want to finish everything, how basically this activity differentiates and how much time delay can happen because of that can be easily planned. The last one is on the solution called Tekla. It's an intelligent parametric BIM tool for constructible design. And what it does, you see how quickly it monitors. This is a simple example of a pier where the reinforcement is very, very difficult to a lot of people understand how the bar bending schedules. But these are the parametric algorithm based model which can be easily populated and gives us the complete cost quantity before the execution starts. Similarly, there are a lot of elements related to post-tensioning and all goes, and then these solutions easily makes them available. This is one simple example. Not only concrete but types can be prepared in a much faster time because the content is available in its full form. Nobody thinks about the formworks because the construction happened. The formwork planning is very, very important, and these tools brings the formwork planning as part of the overall digital prototype when we are creating. And then what it gives, the drawing is the outcome of these digital models. So we don't need to spend time in preparing these hefty drawings. These are one-click outputs we get. And then finally transfer that to the site. So all in all, what it says, deliver with confidence. If we are able to prepare this digital data like well in advance and keeping the transparency across the stakeholders in project lifecycle, we can make it is really easy when we deliver these projects without time and cost overrun. Thanks, Kashiraz, and sorry for a little overrun.
No worries. Thank you so much, Harsh. I think you pretty much tackled every single challenge that was put forth by Mr. Amarendra earlier in his presentation. And without any further delay, I request Mr. Manoj Kumar Gupta, the Chief Engineer for Uttar Pradesh Expressways Industry Development Authority, to take the stage. Sir, please.
First of all, I would appreciate the organizers, Mr. Trimble and Geospatial, who organized this webinar. I am having an experience of 40 years in highway construction. Right, I graduated in 1981. So I worked with many organizations like NHAI on many expressways. So the expressway, the Greenfield Expressway, is the demand of hour. We should construct as many as possible because our country is having huge population and huge four-wheelers, transport, huge transport to cater. The big challenge before us is to find the good investors. By use of technology, we can go for transparent bidding. This is the first basic to get good investors. Then for project planning, we should use all the new technologies as in UPIDA. UPIDA came into existence in 2007. Agra Lucknow was the first project for UPIDA, which we started in 2014. And we completed this 302 kilometer 6-lane expandable to 8-lane expressway within a time of 2.5 years. And now it is operational and it is earning a huge amount, rupees 402 crore per annum as toll collection. So it is a very good model for executing expressways. Similarly, UPIDA took up second project, that is Purvanchal Expressway. It is 341 kilometer long. We started its construction, you can say that date of appointment was given in October 18. And at this time, we are near to finish this project and get it operational within a time less than 3 years. So the good management and good planning, better planning with the use of technology can give us result. So it is more essential for the investors, for the contractors to have faith in the organization where they are going to work. If the organization is transparent, they are using better technology in project planning, in project construction, in project monitoring, in timely payment. So definitely more and more investors, more and more contractors will be attracted towards this highway industry. When we went for bidding of Bundelkhand Expressway, it is a 296 kilometer greenfield expressway. The DPR was framed within a year with all new technology. We used many softwares. I can name them. For survey, we use Total Station. For geotechnical survey, we use Geo5. For flexible pavement design, we used IIT Pave. For highway design, we used MX Road Civil 3D. For structural design, we used State Pro, Midas, MS Excel. For cost analysis, we used MS Excel. For economical financial analysis, we used SDM 4 version 2. Right. Now, when we went for bidding, we decided to construct it on EPC mode. EPC mode has an advantage that if a contractor finishes work early, before time, then he gets bonus. So the incentive oriented scheme attracts the contractors and they try to bid aggressively. In Bundelkhand Expressway, we got bidding at 12% average below rates. So we already, since beginning, we saved nearly 1,200 crore rupees for state exchequer. We started work in February 20, and within a span of 16 months only, we are able to achieve 55% progress, physical progress, and almost 50% financial progress. The project, in this project, we are using all the new technology. For Yamuna Bridge, we are using launching girders. Segmental girder have been casted, precast, and by help of launcher, we are launching them. For checking of density, we are using nuclear density gauge, non-nuclear density gauge, because it is an important aspect of quality control. We are having 3-stage quality control. First quality control is being done by our EPC contractor. Second stage quality control is being done by our authority engineer. And third stage quality control is being done by external technical auditor. UPIDA has appointed Messrs. Wrights as PMC cum ETA. They are our project management consultant as well as external technical auditor. We are having a very close watch on quality and progress both. We have developed an app which gives us daily to daily progress of each package. Each activity is being monitored closely. The main success of UPIDA is due to our land acquisition team. We are able to provide encumbrance-free land to the contractors. At the time of agreement, at the time of appointed date, we were able to provide 90% land. And then within 6 months or 1 year, we have been able to provide remaining 10% encumbrance-free land. So unless we do not work as a team, we can't get success. For every project, if you want a fast project, because public what wants? If we are initiating a project, public wants output. They don't want to listen that a project is lingering for 10 years, for 12 years. And the investors also lost faith because their money get blocks. So we should develop such mechanism with the help of technology that we go faster and faster. Now UPIDA is going for a very big project. It is a 594-kilometer length Ganga Expressway. It will start from Meerut and end up to Allahabad, Prayagraj. The DPR has been approved by government. We are trying on triple P mode, right? So if the investors are having faith, so many foreign investors from Malaysia and South Korea are coming to invest in India for Ganga Expressway. They are willing. They had many meetings with us. Our Chief Executive Officer, Mr. Avnish Awasthi, is a very dynamic leader. At government level, we are not having a single issue. All issues are being resolved within no time. All issues related to design, we are resolving in no time. There is nothing pending for contractor to say that please resolve it, then we will work.
Mr. Gupta, I'm so sorry, but we are running out of time a bit.
Okay, no problem. So by the use of technology, we can go faster construction. We can have transparency, all safety measures, and then ultimately we have to come for ATMS for road users to get the information, intelligence traffic control system, so that a good highway for facility of road users is available with all the information and all wayside facilities, petrol pump, dhaba, etc. And all facilities should exist on highway. That's all. Any question from you? It is welcome.
Of course, Mr. Gupta. Thank you so much for acknowledging our request firstly and coming here and presenting your narrative through this talk and providing us all these crucial insights, including the accomplishments that you have made within the organization and the type of technologies you were able to adopt through the project lifecycle, etc. Unfortunately, Mr. Amrendra had to leave us due to his prior commitments, but otherwise we can have Harsh on stage as well to take a couple of questions before we end this session. Harsh, can you please join the lobby? All right. Either way, Mr. Gupta, a lot of accomplishments were put forth, like I said. I would like to know what are the major challenges when it comes to these type of technology adoption across the project life cycle. How easy or how challenging do you feel these technologies are in terms of accessibility and usage? A couple of words on that will be helpful.
As I faced in project preparation, we are hiring consultants. So there is no hurdle in using any new technology.
Okay.
Whatever the new technologies are available in market, our consultants are trying to bring them and acknowledge them in preparation of DPRs. And
we have one more question from the
the
audience.
Yeah.
Okay, please go ahead. Yeah.
And during construction, some progressive contractors, they are using more new technology and some are not using, but it is a EPC contract. So design has to be done by contractor.
Right, yeah.
And the maintenance is also with them for 5 years. So we are not pressing them hard, but some progressive contractors, they are bringing new softwares to monitor the progress, to prepare the work program, to prepare day-to-day programs, and to monitor all their reports.
Understood. Right. So it's basically project scheduling and sequencing, to name a few, where you use these type of technologies.
Yeah.
Harsh, maybe you can take up this question. This is with regards to the quality control on site. The question is, what are the new technologies that can be adopted for quality control on site?
There are multiple things. The first and foremost, as I said, the data preparation, the digital model is very important, and the quality control portion, you say there are new mixed reality tools which are there. So whatever has been prepared, and when it is going for execution, the use of mixed reality and augmented reality or virtual reality can be used. The second most important thing, how this digital data gets transformed to the machines, right? That is important. There is no data loss in between. If something has been prepared by manual intervention, we heard Mr. Pandey said that how do we actually remove the manual process in this? So how this data getting ported onto our machines and automating this operation, I think that can bring a lot of efficiency in overall quality and safety aspect.
Yeah, definitely. Right. In fact, for highway project, the utmost thing is density of each layer, right? So that has to be checked at site only, right? And that has to be recorded with RFI. We are using nuclear density gauge and non-nuclear density gauge for speedy checking of density.
Right.
And in laboratories, all tests, the laboratories are fully functional as per MORTH guidelines. So all the tests are being conducted there, and data are being kept manually only. we we have suggested contractors to use some, just like you gave lecture earlier, to use some software to have data, but it is not practical. In fact, what is happening at the ground root, that contractors' personnel are changing very fast. They are not stable. So
Right.
the manpower which are keeping the data, the training of those persons is required.
I want to add
It will
something
come
here.
when the industry will grow. When the industry will grow, automatically such type of person will be with contractor, and they will use
Understood. Right.
such
Mr.
type
Harsh,
of tractor.
yeah, you can,
Yeah.
yes, please add your
Yeah, I was
observation.
just trying to add what Mr. Manoj was saying. Nowadays, with most of the machines which are coming, like compactors, let's say, are coming, these devices can be installed into these compactors, like at what temperature, how many passes are being done, and based on that, have we reached to the proper density or not? This is a continuous mechanism now, is already being installed. And this data, like how many machines are working, we can set up a control center. So irrespective of whether the personnel is available, whether they are changing or not, it is completely machine driven. As the machine is doing these operations, this data can be directly fed into the control center, and we can see. So just want to add this, with the use of technology, we become person independent and more like process dependent. So just
Mr.
side
Parikh, you are
note.
right that way. One of my contractor, he is using GPS in all their uh, equipment. So by sitting in Jaipur, he is controlling that which tipper is moving how many kilometers. So this is use of technology.
Yeah.
Yes.
Which
All
tipper
right.
is working and which is sitting ideal, how many trips they are doing. So this is all use of technology. Everybody is having GPS in their all the vehicles, whether it is a compactor, whether it is a loader, whether it is tipper. So the
You're right.
use of technology is increasing day by day.
Absolutely.
That's good to know. Thank you, gentlemen. Thank you, Mr. Gupta. Thank you, Harsh, for joining us, and thank you to Mr. Amrendra as well for this wonderful discussion. I wish we can keep talking, maybe in another event, hopefully soon. In the meantime, I hereby announce that we are going to be taking a 5-minute break. We'll come back at 11:55 for the second session on advancing quality and productivity in airport and highway construction using 3D machine control system.
Hello everyone, welcome back. I'm Siddharth Verma and I'll be moderating this session. I'm Senior Research Analyst in Geospatial World. So the session on advancing quality and productivity in airport and highway construction with 3D machine control systems. So in this session, we'll focus on machine control systems which have gradually relieved the stress on the AC industry due to skill gap and performance constraints associated with equipment and machines. Also, the stakeholders on site have benefited from the near real-time updates, progress tracking, and remote inspection, resulting in enhanced productivity and improved quality of on-site data. So to begin with, it is a pleasure to introduce you to our speakers and experts. We have with us Mr. S.P. Rajan, Head, Plant and Equipment Division, L&T ECC, Colonel Parikshit Mehra, Project Director, Sela Tunnel and Atal Tunnel, Border Road Organization, and Mr. Roshan Purohit, Regional Manager, Civil Engineering and Construction Division at Trimble. I would like to request the attendees to please send in their questions via the chat as our speakers are presenting. We will be taking up your questions during the panel discussion at the end. Now, I would like to request Mr. S.P. Rajan to take up the stage.
Yeah.
Okay.
Am I audible?
Yes, sir.
Yeah. Hi. Okay, it's 4 minutes before good afternoon. Anyway, good morning, everybody. Right. It's very. I hope all are safe in this pandemic situation now. Well, we heard. I was fortunate to hear Mr. Pandey and various others. I'd like to just bring a kind of small recap of whatever he said. He wanted fast, quality, safe, and sustainable construction that could avoid delays, eliminate human intervention, and direct loading of data pre and post, and also an accurate data. So, well, I'm part of construction industry since about, say, 35 years. And well, I'm also part of that 2 kilometer to 37 kilometer per day now. And this 1.7 lakh crore has got a lot to do now. And certainly, as he said, if you don't catch up with technology, we are going to be missing in the world, right? In the competition in the world, right? Well, so we were having the same agenda with us, and we were searching for where our losses are, and that is where we heard our service provider also speak about it, and he had to literally sell the concept, saying that this is where you're losing in terms of time, in terms of material, and certainly in terms of little bit of quality also. So the service provider had to do a lot of exercise in making the people understand, who used to say that for the past 80 years, I've been doing the work in the same manner. Who are you to come and tell us now, right? That's how it all started. So what we wanted was, we wanted some kind of support to improve the earthwork. And that earthwork was done normally by motor graders. So we wanted some kind of automation of motor graders. That's where it started. And what happened? The internationally, these motor graders do work with 3D systems. Whereas when it comes to India, like I think Mr. Iyer said, and as Mr. Pandey said, we could not afford that particular technology because it was almost costing equal to the cost of the grader. So we had to see, like a typical Indian innovative way to see how to innovate and use them in line with Indian environment. So we said that, you bring some components from there, let us make some components here. Whatever is available in India, why not we use them? That way, they were also very cooperative. I think Mr. Roshan is going to talk now, and he's going to probably share all his experience of that kind. We went for a 2D system, not a 3D system. And 2D system also had its own plus and minus. In order to get a hangover, what is this automation? So we went for 2D system. And once this 2D system start getting some kind of acceptance among our people, we could understand that if we develop upon this, we can certainly make a good impact on this in terms of accuracy, time, and various things. So we took interest along with our service provider to go to the US and then see practically what is happening over there, how this particular 3D system is working, and what are all the things that can be improved. And surprisingly, we could see that on a very vast area, one old person of around 65 years, he was driving a motor grader. Nobody was there in the surrounding, not even a crow. So this guy was doing this particular level, and that is when it motivated us. And I also could get a chance to operate an automatic the excavator. Then we thought that, yes, this is the time for us to implement over here. And same typical Indian mind, we wanted to mix and match. So we brought here and we tried. Fortunately, we had a couple of airport projects where we could get a lot of space to play with. So we started all these things at airport project. And the 3D system also has got a couple of what I can say, the mass. So I'd like to just show you how it is. So we can see here there are two masts. So we did not want to use these two masts. We said that we will use only one mast and see what happens. So we tried to use this single mast, and this single mast proved better than the 2D system. And the hydraulics also, we could make something locally, and then we could get some kind of comfort over there. Suddenly came kind of obstruction from a civil fraternity, saying that, oh, this is not giving me a good accuracy. You guys are saying it can give plus or minus 15, whereas this is giving me 40. This is faltu, throw it away. All these things, these are all cosmetic. Then we could understand that they did a fundamental mistake in the benchmark itself. So it took a lot of time for us to sell this concept among our people. Then we understood that single mast also is not sufficient. So we went for double mast. Now today we have more than around 35 units with this double mast 3D system that the operators are so comfortable with. We don't have to go for 20, 30-year experienced operators. We need to just go for for such an operator who has got the compatibility to use this equipment. So operators are comfortable, and a situation has come when we wanted a grader to be released. The civil engineer was willing to put in his papers, then release this particular grader, such as become the acceptability of this equipment. And you won't believe they are now taking this grader to a surface to check what is the level instead of a leveling equipment, right? So having completed this particular grader process, we also went ahead with various other options. Well, let me just take through how earlier we were doing that. We could see quite a lot of pigs around and so many people moving around, with a tape and theodolite, and a man walking ahead of the grader like a kind of elephant being guided. Today you can see no person in this particular surrounding. This is my environment, one of the actual pictures we have shown over here. This eliminates the stakes, strings, human safety hazards, and daylight constants. But what is surprising here is I can even use it during the night time with the same kind of accuracy. This is the onboard controller, and during day how I use, and during night how I use. One such situation came up wherein we had to use around 6 graders at a time to grade a very vast area, and within 12 hours we could achieve what we could have done at least for 10 days, right? And having done this, what are all the solutions we have now deployed at in LNT, or 3D control system of grader? I've discussed that. And we have done 3D excavation also, and 3D paving also. So let me take you through the excavation of drain. So this is the trapezoidal drain, which we were doing. We were doing at the rate of somewhere around 40 meter a day. This has jumped to 120 to 150 meter a day. This is how it is, and the operator is guided by this particular shape which we upload on the system. Like Mr. Pandey says, it's eliminating human errors and also direct loading of the data. By that, he is able to go keep the, what I can say, the bucket, and get to know that how much he has to go deeper and what shape he has to make. He comes back completing that exercise without anybody's help. Only the surveyor goes there to check whether this has been done properly or not. And then paver. So this paver also, you all know that paver takes 2 strings along, and it needs a lot of time to set them up. By going for a 3D system, we don't need to have all those things at site. It's a quick setting and accurate process. So this also has been developed over there, right? What are my challenges? My challenges are simple. One is, even though I've been very successful on airports, I'm now slowly taking baby steps on roads. Network is a very, very, very big problem. We need to improve upon network because somewhere it is catching, somewhere it's not catching. That's one major problem for me. And another thing is, of course, everybody knows that India is running through what I can say L1 process. So when you introduce all these things, they do mean cost, and we are unable to be L1 under such circumstances. And interest among the users, they need to now we had to literally sell this particular concept from top to bottom to make them understand that this has got benefit. So the interest also used to fade, and people who have used it, they are comfortable, but people who have not used it, they need to put in a little bit of efforts in understanding this and also facilitating the people to use this comfortably. Finally, they all say that I've been doing like this industry is like this for the past 80 years. What you guys have come here to teach us, just take this away. It's wasting my time. You see, you've been sitting it for 3 days and nothing has happened. So that patience is not there among the people. And finally, sustainability, like, okay, fine, I'm using it today, but can I use it tomorrow? Will I be able to use it for next 5 years? So these are certain challenges I do face, and we overcome them successfully. Thank you very much. It's a very short time given, so I'm just making it as fast as possible. If there are any questions, I'm here to answer. Comfortable. Thank you.
Sure. Thank you, sir. You wonderfully explained with example how we have innovated ways with mix and match to make use of technology in an efficient way, and how we are moving from conventional practices to data-driven construction practices. Thank you so much. Now, I would like to request Colonel Parikshit Mehra to deliver his presentation. Over to you, sir.
Yeah. Hi. Good afternoon, everyone. It's 12:10, and first of all, I would like to thank the organizers to have me here on this platform. I've been listening since the morning, and probably I come from a thorough tunneling background, so I might be slightly out of theme with things. I've tried to keep my presentation very short and probably just to bring out as to how tunnel construction can benefit from the technologies that are available today, and what is the scope for these technologies to come into the construction practice as we have in the industry today in India. I'll not waste much time. I'll come on to the presentation. So I'll very briefly cover as to what are the challenges being faced by the tunneling and the underground structures construction in the country, and what is the relevance of data-driven technologies to such type of construction. Today tunnels are very relevant. They're relevant to roads, they're relevant to rails, to metro systems, obviously to the hydro industry, and to a lot of miscellaneous assets which are being created across the country for security purposes, sometimes because the cities are now short of space. So underground structures are today very, very relevant, and we popularly say in our field that the future is truly underground. But what ails it today right now is that it's a very diverse field. Even if we see the geotechnical environment, shallow tunnels, which would be metros, subways, roads, road tunnels or rail tunnels, they will generally be made in soil, and the deep tunnels would be highway tunnels in the Himalayan region, in the north and northeast regions, and also for the hydro projects in these areas, would be constructed through rock. Now, these two environments themselves, these geotechnical environments, have a very different behavior. These are two different ball games altogether. So the way to approach them from the design phase to execution to monitoring and to operating is they're different sciences altogether. Coming on to excavation means, today for underground structures, we have the mechanical means, which would be the metro TBMs, tunnel boring machines or earth pressure balancing machines, slurry machines are available. We have some excavation happening through road headers. We are also using TBMs for deep tunnels. The experience in the country as of now hasn't been very great, barring one or two projects, but the technology is improving, and more TBMs are coming for deep tunnels as well, especially as the railways forays into more tunneling in the north and the northeastern regions of the country. Drill and blast again. The technology is basically using drill boomers, using explosives and blasting and mucking. Majorly being used for deep tunnels. The Atal tunnel, where I was director, we did that complete 9 kilometers, under 2 kilometers of overburden using drill and blast. Metro systems, the cross passages would generally be drill and blast. Some amount of drill and blast technique or the new Austrian tunneling method would always be required to induct the TBMs themselves. So this remains relevant as well. Obviously, what happens in a complete project, making the right choice is very important. The tunnel boring machines or any of these major mechanical excavation equipment they're expensive, and we have to ensure that when we get them on site, we have utility for them, and we are able to complete our projects with them. So making this right choice is very important, and this choice has to be made in the phase of investigations, explorations, making the DPR, so that the contractors, when they end up doing the work, get the right equipment on site. As I said, shallow tunnels in soil are slightly easier exploration because we are talking of shallow overburden depths. We can pick up the data easily. The area is generally accessible. There are lesser risks comparatively. Scope for damage control is there because these TBMs, even if they were to get stuck somewhere, we would be able to take them out by doing shafts. The strata itself is semi-infinite and nearly isotropic. So analyzing that data, designing is easier. We're basically designing on overburdens on the tunnel boring machine itself and on the opening. It's more of a structural design. And utility mapping, yes, is a major challenge, especially in the cities. Delhi Metro, they've been surprised with so many things when they were doing excavation in the early phases, because it was very difficult to map the utilities which were already there underground. Deep tunnels, obviously the exploration is complex because there are accessibility issues. Even in Rohtang we had boreholes, but boreholes were generally close to the portals. The mid reaches were not accessible. Nobody could have taken up a rig there. There are larger unknowns in rock in general because it's a much more heterogeneous medium. And then there is higher risk. There's extreme heterogeneity in the type of rocks because we are in the Himalayan region, and we understand that the Himalayas are in a subduction zone. We are tectonically active, so that adds to the challenge. Basically what I want to bring around is that when we are doing tunneling in our north and northeastern parts of the country, there are a lot of unknowns in the system, and that is a challenge. Now with the experience that we are having in tunneling over the past 15-20 years, we need to collate the data, collate the knowledge that we have, so that we can do slightly better. There is diversity in forms of deformability of the rock itself, because there are various types of metamorphic rocks. Most of our rocks where we are doing tunneling today in the country are metamorphic, very difficult to predict them. There are issues in actually predicting the correct discontinuity patterns, doing proper stereographic projections and all. To actually measure in situ and induce stresses in the area becomes difficult at times. There is an isotropy in homogeneity within the medium itself, in the intact rock itself at times. And then we add to it the Himalayan geology, where we have a mountain range which is moving up 4 to 5 centimeters every year. So there are a lot of unknowns, but there are solutions. We end up today using solutions from across the world, where we use some systems from Q systems or RMR systems. These are technical terms, would be known to people who come from tunneling backgrounds. But we must always realize that these systems are also based on case studies which were either in the Norwegian region or they were in the African deep mines. And when we try and use them in India, we must be careful, because our kind of rock will never be akin to what was found in those regions. So what is the best way ahead? Best way ahead is to do a proper scientific exploration program. Use geophysical methods. Today we are using aerial methods as well, where we have airborne E&M surveys being carried out. We are doing borehole investigation technologies. the best way to do it is to do it much before the project is to start, so that we get time to actually do a proper investigation campaign. Because most of the times these investigation campaigns end up being pushed because of the project is required to start very early. So we must start these investigation campaigns at least 4 to 5 years before we want to actually start doing tunneling in the deep tunnel range in the Himalayan region. Then we need to get to geomechanical characterization, which means that we need to characterize a rock based on how it is likely to behave when we are excavating, and how can we support it with what kind of support systems. We need a robust preliminary design, so that our contractors can bid fairly. And we have to give them a tender with a baseline where we tell them that this is the geology that they should expect, because it is very difficult for a contractor to mobilize the kind of resources we need to mobilize for a tunneling project without having good data and without having a good baseline. We have to realize that if we have to take on tunneling in the difficult regions of the country, we as clients in the government will have to share the risk. And that's why these baselines are very important. We have to give our contractors a geotechnical baseline. If the geology is worse than what was given in the tender, then the client will have to take the risk. And subsequently, when we are actually doing tunneling, we need to monitor. We need to do deformation monitoring, and we need to optimize the support systems as per the rock that we encounter. Only then will we be able to do an optimized tunneling, tunneling practice. Otherwise, we will end up always putting in more supports than what is required, or pushing too much risk towards the contractors and make most of our projects untenable. Now, where is the relevance of data and automation in these systems? I'll bring out some points which I think are very relevant. Preparation of DPRs, investigation and exploration. It is in this phase that you decide as to what is the alignment, where should be the adits and shafts be. See, any segment of deep tunnels which is more than 3.5 kilometers is very difficult to ventilate even during construction. And even if we end up making these long tunnels, we have to put in a lot of operational cost to ventilate them. So this is the stage where we need to analyze this properly, and this is where probably good survey techniques should come in handy. At this time we have to give out the likely project time, because in tunneling projects there are a lot of overhead costs that the contractor has, and we need to correctly predict for him the number of years that he would be required to keep his setup there. So this phase is extremely important. We need to find out if there are more attack points, because that means that we can start at multiple points and probably we can reduce the overall project time, and also probably cut the tunnels into smaller ventilation sections. We need to give out the equipment to be used, which a DPR consultant should be able to suggest, so that we get the right inventory on the site, so that we get the right equipment on the site, because most of the equipment being used for tunneling are expensive equipments, and there is no point of having an equipment on site which you cannot use after a certain phase. Design phase optimization. Once we've done with the DPRs and we are sure, we need to optimize by analyzing the rock that we found during the investigation phase, giving the correct excavation and support sequence which will be required for safe tunneling. And we need to ensure that we do not give too many types of designs to a contractor, because it becomes untenable for any contractor or a consultant to take these decisions on site all the time. It's better to restrict our rock types into 4 or 5, and our support types into basic systems of rock bolts and shotcrete, whether it is with a wire mesh or with fiber reinforced concrete, so that the inventory can be controlled and the setup at the site doesn't become too complex to handle during construction. Characterization.
Sorry to interrupt, sir. We are running out of time.
Okay, I should take 1 more minute. Doesn't matter. Characterization. Geomechanical modeling I've already covered. It's important that we take in local experience and intelligent predictions. We need to collate data. We don't share data in the country. That's a major issue. Construction phase, obviously, observation is very important. 3D, without 3D monitoring, you cannot optimize supports in tunnels. So 3D monitoring is important, which can be automated very easily with these moving total station equipment, can pick these deformations and tell us if we need to reduce or increase the supports. CAD-driven drilling, when we are using drilling jimbos, inertial systems, because non-magnetic service systems are important. In the contract phase, understanding advance rates, time-related costs is important. I've touched this before as well. And then finally, in the operational phase of the tunnel, again, deformation monitoring continues in a lot of sites when we are not too sure about the stability. For fire safety and traffic management, we need to pick up the environmental data if the smoke, the carbon monoxide, or the NOx gases are as per the required health norms or not. All this needs to be SCADA controlled. So there is so much of scope of automation of having data-driven inputs in the tunnel from the exploration phase right up to the operational phase. And to be very honest, I don't see much available today in the Indian market for tunneling as such. I'm done with the presentation. That's it. Thank you.
Thank you, Karan Parishad. You briefly explained the challenges of tunnel systems and how the future is truly underground. We'll explain, and with such uncertain geological situations, how using physical methods, aerial methods, we can optimize the tunneling process. Thank you so much. Now, I would request Mr. Roshan Purohit to start with his presentation.
Okay. Good afternoon, everyone. So good afternoon, everyone, again. And in this section of presentation, I'll be talking about connected site and the technology those are involved in this connected site solution. Now, as Harsh presented in the previous session, he was talking about the connected construction continuum, and connected site is a piece that basically address the earth moving positioning, earth moving solutions in the linear projects. So as a start, Mr. Rajan, we as industry will love this slide very much. So I'll talk through this slide again. So there are two different processes that is involved in the construction site. On the left-hand side, the process is very manual, where there are a lot of people putting a lot of stakes, guiding all activities manually, and the data transfer between stages is through paper information. But on the right-hand side, we put technology on machines, use the digital data, design data on the machines to provide guidance and information to the machine. So the machine, the operator can position the machine, at the right level from the first instance itself, constructing a very efficient grading or the processes. So typically, on one side, there are a lot of people telling expensive machines and expensive tools what to do with that. On the other side, technology is making the machines and assets intelligent enough to understand, what is expected out of it. Okay, so the basic question is, which system is more profitable and more efficient? Okay. Now, coming to connected site, I mean, when we talk about data-driven digital construction, connected site is kind of at the heart of it. And as the name suggests, basically in connected site solution, it enables the communication and connectivity between office and designers with field staffs and machines to push the design data, design updates, and receives the progress report and as-built informations. So it's a kind of two-way communication that we are talking here. So the connection or communication can be between the office crew and just one machine, or it can be with multiple machines operating at one site or at multiple sites. Okay, so connected site solution typically enable the data management and the data supervision and control, across multiple sites, bringing the information back to office, which can be used in a dashboard form to provide information to managers and for project management purpose, okay, and for advanced decision making. So as Harsh mentioned, constructability is key to any construction. So it's like we are also talking here kind of a horizontal BIM process by creating a 3D digital model out of the existing design data that is available. So the design data may be in digital form, then it's fantastic. If it's not available in digital format, if paper design is available, still we are able to create a 3D digital model. And that model we use across all assets that is working in the field. So maybe it is a survey tool, or it is a grading machines or compaction paving, so whatever machines or assets that is being used, okay, it uses the same digital model across stages across the process. And the benefit is that, right now when we are working in this ecosystem, in this process driven system, then there is no gap in between the stages, and there is no error or no data loss. Okay, so one example can be like the grader with technology using this digital model, grading at a particular level at one site, at the same time generates the as-built information, and that as-built information can be shared with the office, where the digital model gets updated, and this updated model can go to the survey tool, which can be used by the surveyor to do a QA/QC analysis, or to create a cut and fill map, and then this updated information again can be synced back to office to create the 3D model, and the updated model again can be sent to all machine across working at the site. Okay, so it's kind of this process drives a cohesion between all stakeholder and all functions and all machines operating at the site, okay, creating a common platform for operation for everyone. So quickly looking at the technologies that is involved out here, the first one is 3D machine control technology on graders, as Mr. Rajan mentioned in his presentations. So basically the technology installed on this grading machine, which can be a grader, dozer, or excavator, or any grading machines. It controls the slope and depth of the blade and position the blade very accurately at right level, using the design information. Okay, and here in this process, we are focusing on faster production. Okay, so all the grading cycle or earthwork cycle, we expect the production to go up by 2 times, and at the same time maintaining the accuracy to the tolerance level. Okay, and again, I mean, since there is no manual guidance is required, now this grading machines, it can, or any construction machine at site, it can work with the same efficiency, with the same quality, speed, and ease of operation at night as well, further enhancing the productivity and asset utilization, making the ROI much faster, because I'm hearing a lot about cost. So it is all about ROI, and actually we have in Indian market, we have come up with our own experience over the years that today we say the payback time can be 6 to 9 months, on the investment of this technology. So it can be very, very fast. Then similarly, coming to the 3D technology on compaction and paving, here typically, we are focusing on quality. Like the compaction, we can ensure the right number of passes, thus avoiding over compaction and under compaction. Similarly, on the paving, we ensure smoothness, rideability, right layer thickness, etc., to ensure the design standards are met. Now, when we talk about design and grading, etc., I mean, we cannot keep away the survey tools, from the equation. So we talk about survey cycles as well. So there are some specially designed survey tools around to take, cater to the harsh construction environment, and to offer most accurate positioning, that is acceptable to the construction industry. And here again, this tool can accept those digital model to provide control and a reference of the site. And last, not the least, the suites of softwares. These are extremely important. So the office software like Trimble Business Center, it helps creation of the model, Massol, Takeoff, those kind of applications. Then the cloud-based software like WorkOS, Work Manager, that not only facilitates the communication between office and field, but at the same time, it facilitates reporting back in a dashboard format, or the as-built surface information. So overall, coming to like a point solution, what benefit we get, and for illustration purpose, I've used here the technology on a grader. The production can be improved by 100%, huge diesel saving. The accuracy can be phenomenal. Less reworks, increased safety, less requirement of skilled labor. It can work all day, all night. So basically, faster production, more utilization of assets, so leading to more profit. And similar outcome we can see on other machine types like excavator, pavers, other machine type as well. So all put together, if we go for a site-wide implementation, okay, then our benefit is much more. And in this case, we are able to say that certain percentage of the project cost we are able to save. Okay, and that percentage can be extremely significant, and that can be helping contractors or owners to improve the bottom line. So just highlighting few advantages or benefits that we bring with connected site and the technologies involved around it to stakeholders like owners, contractors. So for owners, it is faster and on-time execution. It reduces project cost, collaborative execution of design, higher quality, layer thickness, rideability, compaction. Then creating digital records for audit, future planning, expansion, etc. I was hearing Mr. Pandey talking about a lot of expectation. I believe as an industry we are able to support that. Again, on the contractor side, we talk about faster production, higher accuracy, early completion benefit can be taken. Then lower cost of production, day, night, all-weather operation, higher utilization of assets, higher return of investment, less rework, less wastage of material. So overall, as a technology provider, we ensure not only we provide the point solution, the benefits around the point solution, but we bring a connectivity across the functions, across machines, across activities. Whether we talk about the entire project continuum, or we talk about just the earthwork piece around those activities, and we bring a lot of benefit to the industry. Thanks a lot.
Thank you, Mr. Purohit. It is really encouraging to hear of the many innovative solutions that you are working on to improve quality construction, rideability, while also ensuring design standards are met, and also like how constructability is a key. Thank you for the presentation. Thank you for the wonderful presentations, everyone. I would like to request all the speakers to join in for the question and answer sessions. So, Mr. Roshan, you touched upon the benefits for owners and contractors. So, like, what are the major benefits associated with machine controls in large-scale transport infrastructure projects, like which are spanning multiple states?
Right. You see, today, we are talking about a kind of production per day, maintaining a very high level of, accuracy and quality. I believe, that is something can happen, with technology on board, because you see, when we are using more number of machines, there is a limitation, right? It creates stress around those infrastructure. So I believe, those assets can be optimized well to facilitate, those kind of meeting ambitions. And also, one thing we bring is the visibility, the real-time visibility to all project managers, all stakeholders involved. Okay, so there, what is going on in the field at that particular instance with that machines. And here we are not just talking about tracking of the machine, but we are talking about hardcore production data, right? So it's the earth moving, and the material moving, which is the major cost in a construction environment. Okay, so we are talking about a clear visibility around that. So overall, this all brings a lot of benefit and traction, around the ecosystem.
Thank you, Mr. Rajan, SP Rajan. Sir, at project sites, what is your say on the benefits which you have witnessed with the use of machine controls?
Well, I made a little mention of that in my presentation, of course. See, we have used it on three different categories of equipment. One is motor grader, another is excavator, and third one is the paver. So normally we used to do somewhere around 20 to 25,000 cubic meter per month on motor grader. And by proper application and use of these 3D systems, we can go beyond 60,000. We can afford to even touch 70. So that is the power of this 3D. And same way the trench, rather the drain making, we were doing 40 where we could do somewhere around 120, and the paver also, like. So the 3D system is there to stay, and people can comfortably employ that for higher level of production. Like I can say that it can go in multiple times. It can even bring it to 3 to 4 times if you have a proper operator and a proper interest from the user side. This is how it is. Yep.
Thank you. Colonel Parishad. Sorry. Question for you. For optimized tunneling, what are the different technological solutions you feel can be used in the tunneling operations related to machine controls? Sir, you need to unmute.
Yeah. For most, for optimized tunneling would be 3D monitoring, where we have these deformation targets which are put on the periphery of the tunnels, and you keep monitoring the deformation of the tunnel as to what are the longitudinal deformations and what are the radial deformations on the tunnel periphery. It's based on this that you decide that if you need the amount of supports that you're putting or not. If at one juncture you feel that there is no deformation at all, we actually end up reducing supports as well. So nothing, brings in more optimization. Like in Rohtang Tunnel, we realized that after we started doing a proper deformation control system, we could reduce the number of supports required by almost 30%, which is probably 15 to 20% of the input cost of the project itself. So I think 3D monitoring is the key, especially in today's world of observational tunneling, where we're using new Austrian tunneling method. And the same methods have also now come into play with tunnel boring machines, where these segments are being changed as required by the strata. So I believe that is one. And secondly, the most important critical aspect is the SCADA control that you have towards the operational part. Because when you're operating the tunnel, you need to understand what is the natural wind flow. Based on that, you use your ventilation systems, which is the major part of your input cost while operating the tunnel. Suppose at one point inside the tunnel, you feel that there is too much of carbon monoxide. You can control the dampers. Helps you to ensure that you are giving a safe environment to the tunnel users. Third would be, fire safety. What happens in most transverse and semi-transverse ventilation systems in tunnels is that based on where the fire is, you open up the dampers, you control the oxygen flow to that area and restrict the fire to that area so that you can rescue people out. So these three aspects, I believe, are very critical, where automation and data-driven technologies can really help us.
Great. Thank you, sir. We have another question from the audience. can you please indicate, Mr. Purohit, can you please indicate tentative additional costs for using such technologies for controlling quality in terms of cost of machines?
I'll say, it is about optimization of the assets. When we talk about cost, it is just the procurement cost, or we are talking about the cost benefit that we are getting out of execution of the project, right? So when so it depends, what kind of project, what kind of machine, etc. But typically, on a machine terms, probably we are talking something like 30 to 70% of the cost on different technologies, etc. Which can be recovered by optimizing the number of machines, assets, etc. on the execution side. Okay.
Another question: how the quality of construction of a project can be monitored in real time? This is for all the panelists. Like Mr. S.P. Rajan, you can start with this.
Well, quality straight away goes towards the accuracy, right? And imagine a road constructed up and down, and then again I'm giving the same example of drain going left and right and up and down. So what happens is these 3D systems basically they are the basic software uploaded into the system, and the machines listen to them. There is no personal intervention at all in this. So the quality is certainly good, and it also leads to what I can say, the accuracy, meaning the graders can provide up to say 10 accuracy. Pavers also can do up to say around 4 to 5 accuracy. What more we need, which is very tough under normal circumstances. So technology helps us. So we can put it now.
Colonel Parikshit, would you like to?
Yeah, in the process of tunneling, you put something on your batching plans. Shotcrete is one of the most important aspects. So we do a lot of real-time tests on when we are batching our concretes, because in the tunneling operation you're almost batching 24 hours for a lot of months in the year. So that kind of a thing can help you to ensure that you get the best quality inside the tunnel. I believe that's one. Then is probably, there are tests which are pull-out tests and all, but I don't know if how machine-driven systems should be able to help them. But yes, what happens is that churning this data with the kind of rock helps you gauge the length of rocks, or the diameter of rocks, or the length of rock bolts, the diameter of rock bolts, and sometimes the type of rock bolts that you should be using. So when you're doing this based on a software, or you're seeing the trends on a software, you can always take better decisions. So that helps. Again, with 3D monitoring, if there's something called the trend line of deformations. If you keep monitoring the trend line of deformations, you can end up optimizing. You can sometimes end up adding one support element which will optimize the construction while add to the stability of the underground structure itself. So yes, there is a lot of scope in tunneling.
Mr. Purohit, would you like to say something?
Yeah, you see, from our perspective, anything that can be measured and monitored, it can be controlled, right? So, so we are with technology kind of enabling very high speed measurement and monitoring in real time, or at the site level, right? So the operator, for example, when he's grading, he knows at what level he's grading, right? So he can take immediate actions around that. Or the supervisor, if he's connected with a machine, he knows what the machine is doing. So so that corrective action we can take without any delay. and that helps a lot, improving the overall quality. So that's I'll say.
Right. Thank you. Thank you everyone for the wonderful presentation and for the wonderful Q&A and making it more interactive. That's it. Like, I'll just wind it up for the session. Thank you, everyone.
Thank you. Thank you so much.
Safe. Yeah, bye.
We now have the next panel discussion on connecting technologies to reduce data gaps and achieve higher ROIs, moderated by Ananya Narayan, Director, GW Consulting, Geospatial World. I hand over the stage to you, Ananya.
Thank you, Siddharth. Good afternoon, everyone. Thank you, speakers, panelists, Kasi Rajan and Siddharth, for the two very well-conducted and interactive sessions. Now, please join me in inviting Mr. Ashutosh Maurya, Project Controls Head, Turner India, and Rajan Iyer, Managing Director, Trimble India, for the concluding session on connecting technologies to reduce data gaps and achieve higher ROIs. While we heard Rajan in the morning, a quick introduction to Ashutosh, who has 20 plus years of construction project management experience working in various large and complex projects in India and Middle East as part of core project delivery teams. Ashutosh is currently the project control head manager for Dial Phase 3A, a multi-billion US dollar brownfield expansion of New Delhi's IGI airport. Welcome, Ashutosh and Rajan. Happy to have the both of you here. Just before we get into the panel discussion, may I please request our audience to drop in any questions in the chat box. I'll be happy to take it during this conversation. Also, we will have one single poll running during this panel discussion, and I hope all of you will participate. Thank you. I'll start off this discussion with first from both Ashutosh and Rajan. We already heard Rajan, but a quick 2 minutes on what is your basic idea on today's theme, on today's discussion, and how do we take it forward from here? We see that there's awareness. We see that there is a lot of interest in the users. How do we take it forward from here?
We heard a lot about basically highway projects, and we are using the same thing, Mr. Ranjan from L&T and Roshan from Trimble. They were talking about GPS, greater base GPS, and I was witness to that. I was part of the project where it has been implemented, and to add that, the project, one of the project guys, the section lead, they were using this equipment even for surveying purpose. When there is a confusion, what is the level, they will take a grader and use it. So starting with these enablers, technology enablers, which in a bigger term in the global industry, it is called virtual design and construction. Basically, design is becoming more important part of that, not only the construction. They are very important thing. And per se, the way I see that, what is happening over in construction industry, it is that, there is a virtual world is being created. Virtual world and real world is starting to getting merged now. What we are seeing that, and if we starting with that point of view, the technology which is going to take forward is that before you build something, you are going to have a digital twin of that already with you, which will help you to make right decision. We can talk about once this discussion goes forward what we are doing in Dial for that purpose. So what is happening that we have a digital twin ready. And that digital twin is enabling a lot of decision, including, the material which will be used, technology which will be brought forward, the project management will be done, how much time it will take, how to resolve the complexity and, that human interaction-based issues. So all these things will be designed in a digital twin model before it start to get on the ground. So, and then when it gets on the ground, what we are going to do, we are going to see that these things are getting, what was the digital model was decided, what was the digital model was short of, it is being implemented, in going forward. And then we have what actually built the digital model of that as well. So later on, the same thing can be used for, the operation and maintenance purposes, optimization of the overall life cycle cost of those assets. So this is where the overall, the implementation part is there. Now, what we are having right now is that we are implementing a lot of technology in terms of data acquisition. per se what we are talking, like your SCADA things and all these have been in industry for a very long time. It's not that they are come new. But what is happening that the one major phenomena that is happening is the cloud computing, which is happening, below the carpet from the construction industry. So the data acquisition devices are available now. And there are the data lakes where the data can be captured. And then on top of that, we are going to have a layer of AI, which can help you make a very right decision and recommendation. So not only per se for the limited project point of view, one good decision can be taken. Even if the organization is implementing such technologies, virtual design construction technology, that can be helpful for even making replication of those things, cost optimization of life cycle of the particular project, and taking better decision in the upcoming projects as well. So this is how I take the things forward. Over to you, Ananya.
Thank you, Rajan.
Yeah, I think Ashutosh said it very clearly. I think where we need to start is for the owner. I'm putting a lot of emphasis on the owner to have that vision of creating exact duplicates of physical and digital twin and be able to go between the two seamlessly. That means they should be able to see the physical twin and say, okay, this has really come from my digital twin. And if they want to make any modifications to the physical twin, they first make the modification to the digital twin, make sure there are no clashes, make sure they really understand the entire project scope, life cycle, cost, time, etc., before they even lay the first brick. I think that is an ideal scenario. Because construction is a very complex process, right? You have a lot of stakeholders. As I mentioned, you have the owners, the consultants, the contractor, the subcontractor, the tradespeople. So if you're building an airport, there is so much activities involved from different people. And as I mentioned very clearly, sometimes with conflicting objectives, that unless you have a common stratum, which is what I call as the digital twin, where you create that and digital twin using the various tools. We have the tools, but the question is you have to implement the tools at the right time. And as Ashutosh mentioned, at the very start of the project, at the very concept level, because the later you take it, it's like, people say old habits die hard. So this has to become an old habit of creating the digital twin, because the later you go, the less synergies you have. So I think that again, the onus is with the owner, and the benefits are fantastic. The benefits are many, as Ashutosh mentioned. It's not only for construction purposes, but with operation and management. So if an airport wants to manage the entire air side and land side, of the airport, and not only that, now many airports also have an aero city associated with it, such as in Delhi, and now Bangalore is coming up. So they have a huge number of assets, ranging from a light bulb to a generator to a recycling plant and so on. So there is so many moving parts. If they want to maintain it and reduce their operation and maintenance costs, they have to have that seamless go between the digital and physical twin. So for example, if I know that I install this light bulb at the end of the runway on such and such days, and the mean time between failures is this much, I don't have to wait till it fails to go and replace it in a hurry because an aircraft can't land. I'm just giving a very simple example, I'm saying. But the point is, with proactive maintenance, we can actually reduce the cost of the operation and maintenance. We can improve the efficiency of the running, etc. And practically, this has been seen many, many times. The technologies now exist, as Ashutosh mentioned, with processing power, with AI, with machine learning, with cloud computing, and with the talent available in India in terms of all these technologies. It's immense.
Exactly.
We should try and use that in construction industry. We are literally scratching not even the iceberg, but the top 1% of the iceberg at this point, and we should get down to the deeper level.
Yeah, thank you, Rajan. Thank you, Ashutosh. There's one very interesting thing. I think we did a research last year, and we analyzed a lot of case studies. And what we saw was that technology adoption is much more higher when it comes in the planning and design phase. But when we get into the construction phase, as well as in the operations and maintenance phase, somehow stakeholders are not adopting these technologies, right? In planning and design phase, when we talk about construction software, when we talk about using AI, ML to process the data, synthesize the data, and then share it with stakeholders, that is happening. But in construction and operations and maintenance, it somehow lags. And in case of India particularly, it lags even more. So where do you think is the bottleneck, especially in these two workflows? How can stakeholders or contractors, for that matter, enable technology adoption? So we heard cost is one of the major challenges. So is that a factor that is a bottleneck? What is the bottleneck in this case?
Well, I think it is both a misconception of cost and a lack of skills. Because if you look at the back office where all these great models and designs are happening, I mean, these are being done by engineering graduates sitting in nice AC offices using some of the latest in CAD tools, 3D modeling tools, 3D detailing tools, etc. And then, so it is conceptualized by people with masters and bachelor degrees in engineering. And then when you go to the construction field, you have basically migrant labor doing the construction. I mean, I'm just oversimplifying it, but the point is there is a huge difference in the capabilities now. So what happens is that because the construction contractor is almost seen like over a period of many years employing labor which is basically semi-skilled. I mean, they use some of the best material. I mean, I used to chide my apartment builder that, hey, you have used some of the best marbles, best wood, but your labor is still using that thread and the weight to measure the straight line. So the skill set has to improve, along with the technology, and I think that is something in construction that we really need to focus on. In fact, I work with the Ministry of Skill Development in survey and construction because those are two areas where we have the best technologies in the back office. I mean, we create great detailing models, a level of details at 500. But is that really used in the factory? Is that really used in the field? I think that is where the translation has to happen. We need to develop the skills. The cost part, again, I think we need to educate the contractors that there are various models of bringing in technologies, right? I mean, there are rental models, there are pay-per-use models, there are software as a service models, subscription models that you can bring in. But I think they need to be shown that the return on that investment, as Roshan mentioned, is of the order of months. And once you have that in one project, you can really translate that. So it is a matter of both. Yes, cost is one aspect, and cost will go down as the uptake increases, right? There was a time when Ethernet, every time the Ethernet, whether it is 1 megabit or 10 megabits, 100 or gig or terabit, every time the price per port went down to $1,000 a port is when the thing took off and it became volume. And now today you get gigabit Ethernet routers for dirt cheap. So I think we need to create that kind of a volume in construction technologies, and that can happen if there is a volume uptake because the return is just simply superb.
Yeah. Ashutosh?
Okay, couple of points. First of all, I agree with Rajan that India has everything ready for that. Okay, I mean we have the best manpower. I will share a short story on that. We have demand as well, and the notion of high cost is, in my opinion, is wrong. Okay, I will bluntly say that because I was in Middle East for 11 years before coming to this project, and I have seen things getting implemented. I will share a very short story. In Middle East, suppose you want to start even a small building, even a smaller villa, you have to go to municipality and get the building permit. And if they need basically two things. Basically, one thing is they call is affection plan approval. So what is affection plan? Affection plan is nothing but on the the geo-coded map, you have to provide your plan, and they will map the plan on that map, and then they will provide you approval. During that process, they will check that if that particular plot is having access to utilities, power, stormwater drainage, if there is any utility crossing to that plot and all, they will check it and they will give you the building permit. After you got building permit, they will also check that they will approve your project signboard. And the signboard will be approved. The same signboard has to be provided on the plot. So this is a process so that, before the construction start, all the utilities companies, so municipality will have the central database for utility companies, sewer companies. They are different utility companies. One will be power utility, one will be sewer utility. Then there will be telecom utilities also, and then municipalities' own road network, and all the coordination will happen prior to that thing, right? So this is actually implemented in Abu Dhabi. I was there for long years, 11 years. Now the question arises, this looks very good, right? I mean, that technology and digitization of everything, this should be implementing in India. Now the question arises, who implemented it? When I had opportunity to, discuss with those guys, it happened that one of that either TCS or some other company implemented the whole end-to-end solution. So what I would like to say that the whole set of technology and people, those who can implement, they are available in India. Now that comes the cost of technology. I don't think that when Indians are doing that work in Middle East, well, that should be fitting into Indian budget as well, because it's not going like they are, some Americans are doing, which will be charging very high. So with that thing, when all the technology in India is being implemented by Indians everywhere in the world, so the notion that the cost is higher is absolutely, which I will not agree. Maybe I have listened to other panelists and they were having that notion that the cost is high, which personally I do not agree. We can have debate and analysis on that. That's part number one. The second question is being asked because I am a technologically technology evangelist. You can see I read a lot about technology, and I'm myself into AI and AWS as a personal reading. So the second question is why the technology, not only in India but globally, it is little behind in construction industry. The reason is that a lot of budget for the construction industry comes from the government side. Government side are they it's not wrong that they are the way they are, but they have to go to a lot of bureaucratic process, because the money they are spending belongs to government public. So they have to ensure that whatever the money is being spent, it is this is rightly accounted. So that is where the bureaucracy exists in not only India but all the country in the world, and that is what makes them adoption of the new thing. They are not so encouraged, because there is always a fear of failure when you adopt something new.
True.
So infra projects and all, if you talk about the rate of implementation of technology is slower all over the world for that reason. So now how it can be worked upon? So lot of that, like what did you say, that non-profit bodies like your organization and all, they have to come and champion for those causes, wherein the consensus is made within the government department stating that these technology can be useful for better project implementation. Not only project implementation, but they will be also providing job opportunities, to whole new virtual design and construction industry can be developed in India within a very minor budget, maybe 0.1% or 0.2% or 0.3% budget of whatever the Indian infrastructure, is spending we are going to have in years to come. So a lot of canvassing has to be done for implementation of technology. That's my take on your question. Thank you.
Thank you, Ashutosh. Thank you, Rajan. I think both of your comments suggested that there is definitely a misconception regarding cost, and there is skills and capabilities. It's underutilized. And one thing very clearly that was very well mentioned by both of you was that project owners have to be the focus, and the reason is that the budgets in India, particularly, they come from the government. Do you think in India in particular does lack in terms of a policy for construction or even a strategy for that matter, right? Like we don't have a construction strategy like the UK does. We don't have any BIM policy. We don't have anything specific for the construction industry. Even project requirements or the procurement processes need to be, I believe, much more clearer in terms of what are the technology requirements and specifications, as mentioned by Mr. R.K. Pandey as well. Do you think that is a very critical step that needs to be taken at the project owner level in India, especially in the highways and airport projects, to drive this adoption? Rajan?
Yeah. See, policies are always good, but there in some cases there is no dearth of policy; it's implementation. The kind of implementation strategies that Mr. Pandey has adopted, or for example, now for road survey they have to use LIDAR technology. So those kind of policies exist, but certainly. I think we can have more discussions around the benefits of technology in the construction phase of the project. So as Mr. Pandey explained, that there is a lot of technology being adopted in the early stages, the survey stage, the documentation stage, the project management stage, and so on. But really, what about construction, right? Because all these are connected. The dots have to be connected in order to achieve the synergies for the owners, the contractors, and the subcontractors, and so on. So you can have the best set of wheels, but if your engine is low horsepower, the car is not going to move very fast. Similarly, and vice versa. So I think we are moving in the right direction. The speed can be accelerated. That's why I offered a poster to Mr. Pandey also, that we are willing to come and meet those 200 contractors and explain to them why, by using the technologies, they can benefit. And at the same time, as an owner, they can give some incentive for the contractors to adopt those technologies in terms of better pricing, in terms of QCBS, like quality and control based, or if you have certain technologies, you are allowed a certain leeway. And that encourages. Now, once it becomes second nature, then, everybody just follows that. Now today, LIDAR is a very good new technology, but India has adopted that, right? We went from no telephones to 5G, 4G, and now 5G because of the policies. So I think policies are a very important part of the framework. The second thing is to make policies implementable, implement it, show it to them in the ecosystem. And that calls for everybody, all of us, to work together. The equipment vendors and the technology vendors have to come to the table, and we are willing to do that and create have some creative business model that will help everyone. And once it gets showcased, it becomes second nature to everyone. Today, I am so proud to see that even in the remotest villages, people have started using smartphones and WhatsApp and delivering videos. I can tell you that I've been to some agricultural places outside of Chennai in Tamil Nadu, and the kind of sophistication with which they use WhatsApp to communicate between the farmers and the agriculture department and talk to them about using videos on better agricultural practices, just unbelievable. So that digital mobility technology can do wonders for us, in terms of our ability to adopt these other finer technologies. So I think that, yes, policy is an important part, but we have to implement policies.
Thank you, Rajan. I think that is a very good point. Ashutosh?
I will concur 100% with Rajan, fully with Rajan. Couple of points to add that when I see, because I'm still connected internationally a lot, and then, I'm talking to people all around the globe regarding the technological implementation of construction and per se the whole technology implementation totally. So see, the rate of technology implementation in India is, my personal opinion, maybe the highest in the world because of the various reasons. First of all, we are a very highly IT savvy country. We have a big IT industry, that's one. Second thing is we are lacking with the physical infrastructure so badly that that creates a need of going to the technology, the digital technology. So the implementation of technology as a whole per se of the IT technology and all is already very high in India. Now, when it comes to construction industry, we have to channelize that we have to sit into that bandwagon and say that construction industry is also going ahead. Now, we have technology, we have people already have emphasized that. So what I believe is the most important thing is awareness is the most important thing. Forum, non-profit forum like yours and all can do magic to implement the technology and benefit country to reap that technology immensely. So that is my take on that. We have everything. We have to make people aware and just say that pause your thinking hats that it is going to cost you more. We as a country, our year by year, our per capita, per capita income is increasing. So the gap, what was there to buy something from US is year by year is going to reduce, right? So that is how once we align ourselves, we have our awareness, we are going to implement all the technology. And I'm very sure that going down the line in 10 years, we will be one of the highest technology implementation, because it's not only that China has done on the same line that way. What we are talking, maybe the 10 to 20 years before, Chinese would have been talking that. So they have done it, and our leadership in Central is also in the right direction. That is what I say. Being technocrat, I cannot comment more on the policies and all, But I see that these things are going to happen. Only thing is that awareness is the most important.
Yeah,
absolutely. I think, sorry, just
No,
to add to
go
what
ahead.
Ashutosh said, I think he hit several points on the head. I just want to add that, when people talk about cost, some examples have shown that, okay, you talk about lower cost at the beginning, but by the time you add all your cost of rework, construction, redesign, sometimes the design is being changed while the concrete is being poured, frankly, in buildings, right? So by the time you take all that trap, you have to come across clashes that you have to break it and then redo it. So by the time you add all those costs, you actually exceed the cost if you had implemented technology on day one and did all these things properly. That cost would have been lower. So the concept of total cost of construction has to be, as Ashutosh mentioned, if we put that and if we showcase that, then everybody will say, hey, cost is not a problem anymore. So I agree with Ashutosh in that respect.
I agree as well, and I also think one of the more important points here is while level of awareness is yes a constant challenge, but I do think that the knowledge of the value proposition that people can derive or the return on investment that they can derive from using these connected technologies is far more less. Especially, I believe for Indian highway and airports, we do know that there are success stories, but we don't hear about them much more. The more we hear about them, the more stakeholders hear about them. I believe that will definitely have a traction and attraction of the stakeholders to adopt those technologies. So
I think.
Yeah.
That's true.
Yeah.
Sorry, go ahead. No, I was going to say, I participated in several road-related technology shows, and then for them, technology meant, इस bitumen का grade से दूसरा bitumen grade कैसे कर सकते हैं, or how to use plastic and so on. So I was a little bit disappointed that nobody talked about high technology, but technology can have different meanings. But it is also, our responsibility as a technology company to popularize that. I can say frankly that Trimble needs to do a better job, and so do others in creating an awareness. So we should take up that bonus. It's a chicken and egg problem again, because unless you see a lot of, if Roshan comes to me and asks for budget for marketing, I say, "Mujhe pehle revenue dikhao," and then he says, "Revenue dikhane ke liye mujhe pehle budget, marketing budget do." So it is a chicken and egg problem, but the onus is on us to improve the awareness. Nobody else will do that. We are willing to do that. We have taken a strategic decision to do that.
Yeah, I absolutely do agree, because we had some very good examples from LNG, from Roshan, from Harsh today, and all of them talked about the value proposition, but somehow that's not available when you generally want to look out in the market. So in the paucity of time, Rajan and Ashutosh, any last minute comments?
I think as far as I see that, things are ready. We have to just, make awareness, go and implement it. I have seen, even airport project which I am working right now, it was the whole BIM model was developed before, before the airport construction was planned, and then finishes and all was also put in the BIM model, and then the senior leadership has put VR glasses and looked how the airport would look before it was being built, during the construction. That was one. Even in Bangalore airport, if I know or talk about, they had a BIM model even quite before the contractor was on board. So what I want to say that all this technology done by Indians, definitely taking tools from all around the world, definitely, you cannot do alone. They have been implemented in part and parcels. And the only thing is that we have to believe that this technology is going to benefit and give us a cost benefit result. That is what we have to start with, that belief. Instead of, suspecting that, it is how this expensive you are bringing and will it add value? No, it's not that. We have seen even if a single mobile phone has changed the life of not millions, but billions and multi-billion people, Before, if 10 years or 15 years back, buying this phone would have been a big question on my head, but I just go and buy because I know that it's going to reap a lot of benefit. So with that belief in the construction industry, everyone has to go ahead, look the technology, implement the technology, and government has major role to play to be an enabler and policymakers for that. That's my last statement.
Thank you,
Thank you. And I just want to add to Ashutosh that let's take Chenab Bridge. It's an engineering marvel. And it happened right here in India with Indian engineers. And let me tell you, it is a marvel for not only us Indians, but also across the entire world. In fact, I attended a seminar on entirely on Chenab Bridge, how it was constructed. And it is, so as Ashutosh said, we have the right talent, right? The only thing I would urge is the owners to give the contractors an opportunity to use technology by incentivize them either through early completion or for using technology, higher points, whatever, so that there is a differentiation and an incentive for the people to use the technology. And believe me, once it's like the farmers in Punjab, once somebody gets a tractor that has got an air-conditioned cabin, believe me, everybody wants to get one and show it off. So similarly, I can tell you that all the contractors will say, hey, I have 3D machine control on my machine and it's working like a charm, right? So we want the owners to give that kind of opportunity to the contractors to incentivize them to add technology. And believe me, in no time, it becomes second nature. As Ashutosh said, getting a smartphone today, I mean, nobody talks about these button phones nowadays. I mean, even in the remotest part, they want a smartphone. And the beauty of our population is we are young, we are aspirational, and we can learn things very, very fast. Okay, our young people. So you show them technology and they absorb it like sponge. And then, boom, it becomes a tsunami in the right sense of the word.
Yeah. With that note, thank you so much, Ashutosh and Rajan. This was surely an interactive session. And we definitely got some great insights. Thank you so much. With this, we come to the end of the virtual summit. Thank you to all the panelists, speakers, and everyone out here who participated today and made this virtual summit a success. We had some very good sessions today where we saw accomplishments made by the NHAI, UPITA, L&T in terms of technology adoption, both software and hardware perspective. And we, of course, had Mr. R.K. Pandey emphasize on productive implementation of technology for fast, safe, quality, and sustainable construction. And he did invite technology providers to actively participate in the changing procurement process. We did hear in the second session the gradual transition that is happening from conventional machine control systems to data-driven machine control systems for both quality and productive construction processes. And I'm sure there are a lot of key takeaways from all the sessions today. We did burst a lot of myths. We did learn a lot of new things on how to take connected technologies forward. So with this, I bid you all goodbye. The recording of the virtual summit will be available to everyone in due course. Thank you once again for being here. We really look forward to your participation in our other such endeavors to keep the momentum of technology adoption going strong. Stay safe, stay healthy, have a very good day. Thank you.